Hi everyone, I'm Brandon McWilliams, and I just want to talk to you a little bit about my Google Cloud Platform Essentials course. All right, so first, just a little bit about myself. I started my career working in IT consulting, working with a lot of different infrastructures. Then I moved to a big storage company. I started working with a lot of large distributed storage systems. So I was working a lot with Linux and with a lot of DevOps tools like Puppet and Jenkins. So I've worked with a lot of different infrastructures in my career. So a little bit about GCP, the Google Cloud Platform. For the course, we're going to talk a lot about the core functionality of GCP. So we're going to talk about the app engine. We're going to talk about the compute engine. And for the app engine, we're going to go through a couple of different use cases. We're going to talk about a Sinatra Ruby-based web app that we're going to deploy via the app engine. Then we're going to deploy a Node.js application through the app engine as well. Then we're going to do the same thing in compute. So the thing about app engine is the infrastructure is a little bit more abstracted. So when we get into compute, it's going to be a lot more involved. There's going to be a lot more to do. It's going to be more hands-on. So along with that, we're going to cover some other GCP topics like networking. We're going to talk about machine learning and big data a little bit. We're going to talk about some of the APIs and a lot more. So in order to cover all those topics, we're going to utilize a comprehensive study guide that's going to cover a lot of topic-specific guides within it. Then we're going to have flashcards to really hammer home those important points within GCP. And we're going to have some quizzes for each section. So along with that, we're going to have hands-on labs and exercises that will follow along with the example course content. So I really hope you enjoy it, and thank you for taking the time. Hi, and welcome to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm going to walk you through the Linux Academy platform and show you how you can get the most out of your experience in this course. Okay, so this is the primary dashboard, the home page, once you get logged in. And here, just working from left to right on the top, we've got our logo here. It's clickable, it'll take you to the home page. You've got notifications here. Latest updates will take you to our blog, and I'll go ahead and click in there. Okay, and our latest post is our weekly roundup where we celebrate the successes of our students. We go back. Okay, and then we have this teach button. That's because we're hiring. So if you're interested in working at Linux Academy and producing course content like this course, well, go ahead and apply. You can click here and apply, and there's also a link on the bottom of the page. Here is where you access support. And you can either view the FAQ, the frequently asked questions, or you can ask a question through a few different channels. You can provide feedback here as well. Okay, and here is where you view your profiles. You can manage your profile here and manage your account. All right, and here is another homepage link. Then we have our courses, and our courses are divided up into 7 major categories: AWS, Linux, OpenStack, DevOps, Azure, Big Data, Containers, and we'll have some Google Cloud as well soon. And also from hovering courses, you can see all of our certification courses, all conveniently listed all in one place. All right, and if we move to the right, we have cloud servers. And cloud servers are your instances that you can spin up to follow along on lessons in your course, or just to play with different technologies and try things. I'll show you how to start one up now. So I've got my 6th distribution or 6th cloud server here available. You can specify a distribution, and right now it's set to CentOS 7, and that's okay. So we'll use that, and I will create server. It's as simple as that to stand up a server for CentOS 7. And as it's spinning up, you'll see status, starting, public IP loading, private IP loading, and you'll see these host names. Okay. There's also a 40-day expiration. Every time you log into the server or start it up again, it resets. Also, there's a refresh timeout. If you don't refresh, your instance will stop in 120 minutes. All right, and also your default credentials are right here. You have user as the default user account. Then the user password is 123456 by default. Also, the root password is 123456. Okay, and for Windows users, you can download PuTTY here to follow along. Okay, so I've got my public IP now, so I'm going to go ahead and get logged in here. So, and then I'm going to open up my terminal. And I'm going to paste that in. SSH user, all right, user's our default user. And there may be a delay in being able to SSH into the node. You've got to wait for the SSH daemon to start. So let's wait a couple moments. Okay, so I'm getting logged into my instance now with that default user. And it's going to ask for a password, and then it's immediately going to ask you to set a new one. It may be a little bit slow on initial startup. Okay, 1, 2, 3, 4, 6. Then I'll set a new password. And it'll ask me to confirm it. Okay, so I'm logged into, or I've reset my credentials. So I'm ready to log in again with my new password. All right, and there you go. It's simple as that. I'm logged into my instance, my cloud server, Linux Academy provided cloud server. All right, so that's how you do that. Now, going back, I'm going to go ahead and close the cloud server menu. Then we have our quick trainings listed here, and these are trainings that are 2 hours or less. We have our hands-on labs, which provide real-world scenarios to apply some of the concepts you learn in your courses, in your coursework. And you have learning paths where you can organize a path or set a path for learning, or your company has set one up for you and you follow along. And also there's the community, and you can interact with students here. You can ask content-based questions, but I would say any technical questions with the functionality of the site, you should open up a support ticket. But any questions about coursework or things that might actually be valuable to other students to know, I think it's a good idea to post in the community. All right, I'm just going to click in here. And my view is a little bit different than yours because I'm admin, but anyway, here's the basic layout. You've got your profile here, recent activity, and sticky posts here on the right, and then your main feed here. Okay. Okay, so here is the course page for the Google Cloud Platform Essentials course. And starting off, we're on the syllabus tab. So if we scroll down, we see all of the content in the course. We've got an introduction, initial setup and configuration of the SDK, cloud projects, app engine, compute engine, networking, cloud storage, and administration. Okay, so if we scroll up, I'll kind of walk you through the different types of content. So we've got our video lessons. They have this little play button next to them. Then we have our hands-on labs, which have this little beaker associated with them. And if you hover a little question mark, it'll usually give you a little helpful hint on what something is. Then we also have quizzes here, and that's what this little HTML tag is associated with. And that's about it for this course. All right. And notice you'll get a check mark whenever you complete something. You can set a course schedule here. You can view details for the course here. Any downloads associated with the course would be here. And actually, if you go back to the syllabus, you'll be able to access some details here, and also the study groups. Okay, then flashcards will be here, and community you can access from here as well. Okay, well that's all I wanted to cover about the Linux Academy platform. So go ahead and mark this lesson complete, and let's get started. Bye for now. Hi, and welcome back to Google Cloud Platform Essentials. This is Brandon, and in this lesson I'm just going to introduce you to some of the major concepts in the Google Cloud Platform. All right, so first off, what is the Google Cloud Platform? Well, it's an all-inclusive infrastructure platform. This includes services for deploying virtual machines, networks, microservices, containers, just about any kind of infrastructure thing you can think of, load balancers, all of it. These services make deploying applications easy as it greatly simplifies the addition of services and the management of infrastructure. Services are fully integrated, which makes it very simple to add and adjust the architecture of your application. It's basically just this expansive set of resources available to use to establish and manage your infrastructure. And it's all provided by Google. It's all in a central location. All right, and you'll hear a lot about resources. Resources is how the Google Cloud likes to refer to its different components. All right, so why use Google Cloud? Well, it's that all-in-one infrastructure platform, and it simplifies infrastructure issues greatly. You're gaining a lot of the cloud compute concepts with Google Cloud Platform, of course, but the way everything's tied together, it's so seamless. It's very nice in the Google Cloud Platform. Some might say better than some of the other services out there. All right, and with that, you kind of get the benefit of the scale of Google. So you've got this all-in-one infrastructure platform, and it's going to provide you with features that address issues like scalability, future-proofing. You don't have to worry about hardware failure and other unpredictability. Google abstracts all that away from you. It abstracts away all the complications of building infrastructure. You can take advantage of that scale and computing power of Google. There's a huge selection of integrated services to choose from, and the services are very simple, just oftentimes just like a plug-and-play concept. It's a very nice platform. Everything's fully integrated. All right? So Google Cloud Resources, like I mentioned, all the components within Google Cloud are kind of referred to as resources. They're the building blocks, right? The Google Cloud Resources are what ultimately comprise the Google Cloud Platform. They're distributed across multiple regions and zones, and we'll get a little bit more into regions and what they are and zones and what they are. But each resource maps directly to, or is at least abstracted from, a physical asset in one of Google's data centers. All right, and there's a wide variety of resources, and they're fully integrated. So Google Cloud makes it nice and easy to add and subtract their resources, and it's a nice benefit to using Google Cloud. All right, so regions. There's a region in several different major geographic areas across the world. So we've got regions in Asia, Europe, US. These regions, they're defined by data centers. So there's at least one or more data centers in each geographic region. A resource could come from any region or zone, but not every region or zone will have all the resource types available. Like the App Engine, for instance, it's available in 4 regions, and you'll want to utilize those regions if you intend on using the app in it, right? And it's like that for a lot of different resource types. All right, and here's a list. So like I mentioned, there's a region in East Asia, Northeast Asia, Southeast Asia. Then there's a region in Western Europe, Central US, East US, a couple in the East US, and one in the West. And they're adding them all the time. Right? They're constantly expanding to address their scale. Lots of geographic distribution to add to the resiliency of your infrastructure. All right, so zones. Within each global region, there are multiple zones. For the US Central 1 region, for instance, there are the following zones. There's the US Central 1A, 1B, 1C, 1D, 1E, and 1F. Each of these zones is isolated from the others within the region. This ensures a high level of data safety as long as an application architecture is distributed across multiple regions and zones, which is easily accomplished with the Google Cloud Platform. It's one of the reasons you want to use a product like Google Cloud, to get that distribution, to get that redundancy, to reduce latency from your application if you're addressing a global audience. All right, and then here's the current zones. So like I mentioned, there's central one in the middle. It's got all of those different zones. You've got in East Asia, 3 different zones, and 3 in Northeast Asia, 2 in Southeast, 3 in Western Europe, and the list goes on. There's a lot of different zones, and again, they're all isolated from each other to add to the redundancy and resiliency of your architecture. Okay. All right, so the major products that make up the Google Cloud platform. All right, so product offerings from Google Cloud, they're provided as services. And these services, this list of services, the one you're looking at right now, it's constantly growing, with several having been added since the start of the creation of this course even. I've heard things about IoT, for instance, that look really promising, really interesting, and I'd like to learn more about, but they're always adding new products. We're going to focus on some core components in this course. We're going to focus a lot on App Engine and Compute Engine because those are the typical starting points with using Google Cloud. So they're familiar concepts. With Compute Engine especially, you're talking about VM instances and standing up VM instances, which is a common, virtualization is a pretty common thing that a lot of engineers are comfortable with. So a lot of them will start with that. Then the App Engine's sort of a super simplified platform for deploying microservices. And we'll get into other things like storage. Of course, you're gonna have storage requirements for your infrastructure, and some of the basic networking concepts. We're gonna get into a lot of different things, but we're gonna focus on the core. We'll look into adding more course content as we move forward and getting into more detail on some of the other things. But here's a lot of the major products. And like I mentioned, Compute Engine, App Engine, the Container Engine, which we have a course coming out that Travis is working on, and it'll be out by the time this is released, that you'll want to check out for some Container Engine content. We're not going to cover Container Engine in this course. Like I mentioned, storage, the different data store options. So you go out our SQL, Big Table and Data Store. Then of course networking. Then our big data options. There's an expansive set of big data and machine learning platforms. And then Stackdriver, which is the monitoring and performance platform. All right, so there's a lot out there. All right, so working with Google Cloud. Well, there's several different ways you can configure and manage Google Cloud and the resources within it. The most common way, and probably the simplest way, is just utilizing the Google Cloud Web Console. I'll go through these. Here it is. It's the traditional web GUI. And here's what it looks like. And we'll walk through it. We'll go through the basic dashboard. I'll talk you through all the different options in the menu and activity monitors and panels and things like that. And we'll touch on the web console a little bit as we configure things going throughout the course. Then we have the Google Cloud CLI, and we'll focus on that a lot because this is Linux Academy. We like the CLI, and it's a little bit easier to use in that it's not requiring as many clicks. You don't have to be familiar with navigating menus and things of that nature. So we'll use the Google Cloud CLI a lot in this course. It's a command line interface. It's organized in command groups. All right. So the basic invocation here is Gcloud command group and then command. Right. So we may have a command group called projects and a command called list, and Gcloud projects list would just list all of the projects that are set up for the organization. Or we could have Gcloud compute and compute as the command group, and then you can have a nested command group. So you could have Gcloud compute instances, which is the command group for actual deployed instances for compute, and then you could do a list, and it would list all of the deployed compute instances. So it's a really nice CLI they've developed. All right, there are also client libraries. So if you want to interface with your Google Cloud configuration programmatically, that's a possibility with client libraries. And there are several different languages now. Some of these, again, they've been released since the start of this creation of this course. They now have 7 different client libraries, 7 different native client libraries for managing Google Cloud resources and your Google Cloud configuration and management. So you've got Go, Java, Node.js, Python, Ruby, PHP, and C#. They all have dedicated native client libraries for Google Cloud now. All right, so pricing. There's no upfront costs. All right, so you don't have to pay anything to get set up. There's no initial cost there. In fact, you actually get a free $300 just for signing up, and I'm hoping you can utilize that and not have to pay anything as you go through this course. Really, $300 is more than enough to get through all the content in this course and then some. That's a lot of free credit. And you pay for what you use, and that's a common cloud concept, right? You're just paying as you need it. You only use resources you need. Comparing to the traditional data center paradigm where you're having to stand up racks and racks of servers in anticipation of your user base. You don't have to deal with any of that with this cloud-based paradigm. You just have to be able to scale. If you're on a proper platform like Google Cloud, there's a lot of tools that make it a possibility to scale as your user base grows, as your demand grows. So it's really nice. You just pay for what you use. There's no cancellation fee, right? So you can cancel at any time. It's not a problem. You get discounts for sustained use. So you can save up to 30% just by using things consistently, using your resources consistently, which is nice. You're also charged by the minute. So some other cloud providers, they charge you by the hour or some other period of time. For Google Cloud, you're just charged by the minute. So you're really just paying for exactly what you use. You can save more by using preemptible instances. So if you have workloads like machine learning workloads or big data workloads that you don't require the instance up all the time, you can take advantage of using a preemptible instance that just runs when resources are available, or it's just available when there's an overabundance of compute available. You can save money that way. And they claim that you can save 21% on average compared to other cloud providers. So something to keep in mind. All right, well, thank you so much. I just wanted to cover some of the basics about the Google Cloud Platform in this lesson. So I think we've covered how to manage it, how things are organized into resources. We've talked about the major product offerings, pricing, and and regions and zones, the concept of geo distribution. So I think I've covered all the major things I wanted to in this introduction lesson. So go ahead and mark it complete, and we'll move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Platform Essentials course. This is Brandon, and in this lesson, I just want to briefly walk you through the process of signing up for a Google Cloud Platform account. Okay, so if you notice here, I'm at cloud.google.com, so you'll want to go there. And what we want to do is click Try It Free. Now, when you set up your account, you'll actually be set up with $300 worth of credit for free. It says it right here. Sign up and get $300 to spend on Google Cloud Platform over the next 12 months. So that'll be plenty of credit to get you through all of our interactive lessons. And this gives you access to just about everything that Google Cloud Platform has to offer. And there's no auto charge, so you don't have to worry about that. All right, but you will need a credit card to get that free trial credit. So something to keep in mind. Here we have our acceptances. If you want emails regarding announcements and whatnot, you can check yes there. I'm going to say no. And you'll need to agree to the terms here for the free trial. So read those if you like, and click agree and continue. All right. And you can change your account type here. You can say individual and put in your address information here as well if you'd like. And set up your payment. Then you'll add your credit card here. So I'm going to drop off briefly, put in my information, and then I'll catch back up with you. Okay, so I just clicked start my free trial, and this will take a few moments. It's creating the project. And here you go. So here's our dashboard. And you'll notice it creates a default My First Project for you to start out. And here it says, thanks for signing up for the free trial. We've given you $300 in free credit, so you should see the same thing. So I'll click Got It. And you can take their tour as well, but I'll be walking you through the dashboard in a subsequent lesson. So I'm going to click Got It. And that's all I want to cover in this quick lesson. So go ahead and mark this complete and move on to the next. Thank you so much for taking the time. Bye for now. Hi, and welcome back to the Google Cloud Platform Essentials course. This is Brandon, and in this lesson, now that we have your Google Cloud Platform account set up, I want to walk you through the process of installing the SDK, the Software Developer Kit. All right, so let's go ahead and do that. And the first thing we need to do is go to this URL, https, and it's cloud.google.com/SDK. All right, and I'm on a Linux machine right now, so that's the link we'll click right here, install for Linux, and it should determine your system automatically. So I'll click install for Linux. And it has its own instructions here. So it says you want to verify that you're running Python 2.7 on your system. So we'll go along with that. We'll open up a terminal and I'll type Python -big B. And there it is, Python 2.7.12. And if you don't have that installed, it's likely you do if you're using a modern distribution of Linux, but if you don't, make sure you've got at least 2.7 installed. All right, so let's close that. All right, and then we want to download the archive file. And we'll choose the appropriate file based upon our system architecture. This is a 64-bit system, so I'm going to grab the Linux x86_64 package. Okay, and now I'm going to go ahead and download that file. So it's a tar file, so let's download it and save it. All right, so it's downloaded. So I'm going to move into my downloads directory. And I'm actually going to move that up to my home directory. So, okay. Now it's just a tar xvf and specify the file. All right, and now we can run the installer. So it's in .google cloud SDK install.sh. Just like that. All right, and it's got a little install interactive application here. So this first question is asking if we want to enable usage reporting for the SDK on the system. And I'm going to say no. Let's see, and then on the next step, it kind of shows you which components we have installed so far. So I could scroll up. You see there's a lot that aren't. We'll be adding components as we go, but we've got the basics here. We've got our basics, our Cloud SDK core libraries, the command line tool, and default commands. So we've got those. So that's good enough for now. So I'm going to say yes. I'm going to allow it to modify my path. And .bashrc is fine for me. All right. So now, if I close my terminal and open up a new one, we should have it in our path. So now we can Gcloud. All right, cool. Gcloud -- help. It gives you a man page. All right, so that's all I wanted to cover. This is how you would install the SDK on a Linux system. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to walk you through really quickly how to go about installing the Google Cloud SDK on a Linux Academy cloud server. All right, so here I am logged in on my Linux Academy homepage. I'm going to click on Cloud Servers, and I'm going to start a new server, and we're going to use CentOS 7. All right, and we'll create server. Now this is going to be useful if you don't want to install the SDK in your local environment and you still want to practice some of the Gcloud CLI functionality, or if you're going through a lab exercise, you'll want to go this route as well. You want to install Gcloud on your lab instance and run it from there. All right, so that's spinning up now. I'll check back in a few and get logged in there and start setting up the SDK whenever it's ready. Okay, so I've got a public IP here now, so I'm just going to grab that. And I'm going to go to my terminal and I'm going to log in with my user account. Okay, so now I'm going to go ahead and get logged in, and I'll use the default password. And new password. Right, and I'll get logged in again with my password I just set. All right, so now I need to go to the Google Cloud SDK page so I can get a link. So it's cloud.google.com/SDK. And we see this install for Linux. So I'm going to click on that. And then I'm going to find here the appropriate version. And for me, it's going to be the 64-bit. So our cloud instances, our cloud servers are 64-bit. So I need this x86_64 file. And I'm going to copy that. So copy link location. And then I'm going to go back to my terminal and I'm going to do a wget and the link, and I'm going to download it. Okay, and now I'm going to unpack the tar file. So tar xvf, and then specify the file, and I'll unpack it right here. Just take a couple seconds. Okay, and before we run the installer, I want to verify that we have the correct version of Python. So I'm going to do a Python -v. So we're looking for a 2.7 release. Okay, so we've got 2.7.5. And you should have the same if you're using the same CentOS 7 cloud server image. So that's good. So now, going to run the installer. So it's in Google Cloud SDK that we just unpacked. And it's just install.sh. All right, and it's asking here if I'd like to participate in the usage data reporting. I'm going to say no on this one. And then it's asking if we want to modify our profile so Gcloud CLI commands will show up in our path, and we want to say yes to that. and that's fine on the bash rc file. Okay. So now I should be able to exit and log back in. All right, and I should have Gcloud. There it is. So Gcloud, and we'll just do a help just to show that it works. All right, so there's our help file. All right, so that's all I want to cover in this short lesson. So go ahead and mark it complete and move on to the next. Thanks for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm going to talk to you a little bit about the Google Cloud Console GUI. Okay, so I've got it up here. I'm logged in, and the first thing you see up at the top, it says you have a $300 credit and 365 days left in your free trial. As we go forward and we use resources in our interactive lessons, and we deplete this credit amount, occasionally a message like this will show up when we log in. Okay, and we can just take note of that and dismiss it. It's very unlikely if you just follow the lessons that you'll max out your account, but just something to keep an eye on. Anyway, but this is our console, our GUI console, all right, the default dashboard. And I just want to walk you through some of these menu options and the panels and some of the other menu options. First off, over in the left panel, at the top, we have the API manager. And basically all of these other components have an API associated with them, and that's how they function. And you can utilize the API from the GUI here, or you can use it from the Gcloud CLI tool, which we'll get into a little bit in the next lesson. So basically everything has an API associated with it: billing, cloud launcher, app engine, compute engine, container engine, and the credentials can be managed from here. And you can see a library of all the different APIs, and along with the Google Cloud Platform specific APIs. We have Google's general APIs for a lot of their offerings, like Maps, for instance, or Gmail, Google Docs, all of the APIs associated with Google. And you also have an option for a general dashboard for the API manager. Next, we have billing. So you view all your billing information here. You shouldn't have to worry about it too much during the course, because it's very unlikely we deplete that $300. But if you do add some more projects and have high utilization and you want to check your billing, that's where you would do that. Also, there's this little gift box up here that shows up during the free trial. So if you just want the status of your trial, that little dialog message that showed up earlier, you can view it whenever you want by clicking on that icon. So if I dismiss that, icon repopulates. Anytime I want to check, I can click on that. Then we have Cloud Launcher. I'll go ahead and click into Cloud Launcher. Basically, it's providing pre-configured virtual machines that can be deployed, and there's a lot of different options. So we've got some common stuff like WordPress, the LAMP stack, PHP. Basically, really any basic configuration you can think of, different operating systems, and even GCP specific items here you can launch from here. So it's just a nice, convenient way to view a lot of different options you have for setting up your software infrastructure. So I'm going to click on Google Cloud Platform here. It's going to take me back to the console. That's how you'll get back. You can also click on this little menu button as well. Okay, so then we have support, and there's phone support and community support. Phone support is as you'd probably expect. They've got a list of phone numbers. You can contact people for various problems. And I'll go ahead and click in there and show you. Yeah, so there you go. There's the phone number. And then there's community support as well. And it's got links to Stack Overflow and common keywords to look for in Stack Overflow, and also server fault. So similar kind of voting community style support platforms here. And then you have your Google developers system here and Google groups. And I will click back here, go back to the dashboard. Then we have IAM and admin. And this is where we manage our roles and permissions across our project. And there's various options here, which we'll get into later. Next, we have our compute section. And first, we have the app engine. And the best way to describe the app engine is it has the goal of providing the ability to add the code and deploy. Add the code and go. It abstracts the infrastructure away from the developer as much as possible, but still provides the ability to scale automatically. It's a really nice platform for a developer that just wants to write code and deploy. It's really great for that. And we're gonna go through a couple different use cases later on in the course with App Engine. We're gonna deploy a Ruby web app with Sinatra, and we're gonna do the same with a Node.js. And we'll go over the differences between the two, and I'll talk you a little bit through the architecture, but I'll mainly show you how we can use the App Engine to easily deploy web applications. Then we have the compute engine, and this is more of your standard VM paradigm. If you're familiar with AWS, it's like using EC2. You would build your own infrastructure with this. If you have a distributed architecture, you'd stand up multiple compute engine nodes, and you might configure a virtual network, a virtual private network for the nodes, and you'd configure it in a more traditional IT manner than the App Engine. It's not abstracting away all of that configuration. Next, we have the container engine, and that's a platform for provisioning and management of Docker container instances within Google Cloud. So there's a lot of pre-baked options, and I'll click in here and take a look. There's pre-baked options, or we can create a container, and it takes a while. If you click into one of these options, a lot of times it will say, is getting ready. So it could take a few moments to load up. But basically, what you need to know is it's a platform for managing Docker containers within your infrastructure. So let's just go back to the console. We'll get more into that later. And actually, Travis on our team, he's got a course coming out as well where he's going to take a deeper dive into the container engine. So if you're really interested in container engine, that's the place to go. All right, now Cloud Functions is sort of the serverless platform for Google Cloud. It's made to be even more abstracted from a traditional compute environment where this instance is providing a specific function to your infrastructure, as opposed to acting as a system in your infrastructure. And we've got a lot of content on serverless applications. Johnny, he's got a great course on going serverless. So if you're interested in that, definitely take a look at that. Next, we have networking, and all of your GCP private networking can be done from here. By the way, I'll use the term GCP to describe the Google Cloud Platform on occasion. Google Cloud Platform is kind of a mouthful, so I may start using GCP interchangeably just to save the syllables for you and move a little faster. So anyway, next we have the storage section, and we have Bigtable. And Bigtable's, it's Google Cloud's very basic NoSQL platform. All right, so when we talk about NoSQL, we're talking about key value pairs. It's a simple data structure. And data store builds on Bigtable, so it's another option. It's built on it. It's meant to be more simplistic than a traditional SQL database, but it's providing a hierarchical semi-structured architecture. So it's a little more inherently organized. So that's an option as well for a large web application where you need to store data. Next, we have just the generic storage, and in the Google Cloud context, this is going to be a fully managed object store. So it's like with AWS S3 or with OpenStack Swift, it's an object store offering from Google Cloud. Then we have our SQL, which is just your traditional production level SQL offering for Google Cloud. And then we have Spanner, which is a mission critical relational database offering. All right, and it's a little more robust. So now we get down into Stackdriver. And Stackdriver is your monitoring / performance platform for Google Cloud. This first option is just your basic monitoring, which is providing performance, uptime, and overall health of your applications. Then we have Debug, which is your application debugging platform. And you have to configure debug for your application, but it gives you a nice view into your debug output. Trace as well. Same kind of deal. It's a distributed tracing system for your applications. So it also has to be configured to be utilized. Then we have our logging, and it's a logging service, also has to be configured. It's a logging service for your applications. And error reporting, and it's going to show your application errors. Let's jump down to tools and container registry. That's where we would add containers to be utilized in the container engine. Development is where we manage our source code repositories, and related plugins. Deployment isn't all that interesting right now. Once we deploy some stuff, we'd be able to see some information about our deployments. Test Lab is a sort of a testing platform for Google Cloud. And endpoints are just that they're endpoints that can be configured and utilized within your software project. Next, we have big data, and the first option is BigQuery, and it's a data warehouse for analytics. And we'll test out the functionality a little bit later in the course for BigQuery. It's a really nice platform for interfacing with your data. Then we got our pub sub, and that's a middleware offering for Google Cloud Platform. Then we have Dataproc, and that's the Hadoop stack platform for Google Cloud. Then we have Dataflow. It's a data processing service. We have the ML engine, which is the machine learning platform for Google Cloud. And then we have Genomics, which is a data service catered to the genomics life science industry. All right, so now that we've covered our left menu, all the options, and you can see it's pretty robust. There's a lot there. There's a lot to get through. Now we'll go to the dashboard. So this is the standard dashboard. All right. On the top left, we have our project info, and it shows the basic information for your project. So you've got your project ID right here, your project number, and as we reference our project, if we use the Gcloud CLI tool, which we'll get into in the next lesson, oftentimes you'll have to reference your project by the ID or the number. Those are generally interchangeable ways to identify our project. And there's a handy link to manage our project settings here. Next, we have resources, which would traditionally show us some data about our resources that are in use, but we aren't actually using any yet. So it's empty. Then we have our trace data, which would give you like a summary of trace data that had been configured for Stackdriver. But we haven't configured anything yet, so it's empty as well. And by the way, you can move these panels around. So I can say move this above resources. Then under trace and resources, we have getting started. And there's a lot of handy links for things to learn as you get comfortable, get acquainted with Google Cloud. Some nice links to reference there. And definitely feel free to jump around and look into things as we go on. Here we have the API panel. And really it's just showing the overall number of API requests in this this graphical format. And this spike you see is actually, as I clicked on one of the APIs over here, or clicked on one of the options over here, the associated API took a request and set it up. So that's as we add a new project or spin up an app engine or compute engine instance, you'll see this API spike. All right, and then we have the Google Cloud Platform status. So this is the status for Google Platform as a whole, Google Cloud Platform as a whole. And you can see they've got an issue with the container engine that's been reported. GKE IP rotation procedure does not include FW rule change. So I could click into that and view a little more information. Next we have billing. So we've got our basic billing view here. It's not as robust as what you would view if you clicked over here on the left menu, just an overview. And like I said, it's likely this is just going to stay at 0 during the course of this this entire course, because we're very unlikely to exceed that $300. Then we have error reporting, and this will give you an overview or a graphical view of error reporting. We have Google Compute related news in this panel. And then we have our documentation panel. So learn about some of the major components in Google Cloud. Nice, easy links here. Okay. And then finally, up here, we can click on Activity. And it's going to show a list of activity items. Anything you would get a notification for on the dashboard would show up here. And it's pretty sparse right now. It gets more interesting as we start configuring things and adding things to our infrastructure, deploying apps and things like that. But it's a good overview for all the activity that's happened in your project. So also, yeah, notifications here. Any new notifications show up here. Notice they correspond to activity. So anything that hits notification corresponds to what shows in this activity tab. And you can actually even click this see all activity. It takes you right back to the same spot. Okay. And you can filter on projects, user, different categories, different resource types, and date or time. So there's that. Now if I go back to the dashboard, you'll notice on the top right there's a customize button. So I can click customize and I can add new panels. And I want to do that now. I'm going to go ahead and add App Engine and Compute Engine. Those are two components we're going to use quite a bit in this course. So let's just add those. And I'm going to click Done. And while we're up here, the Google Cloud Shell can be activated by clicking there. And it gives you a little summary about what it is. Basically, it's just a little shell terminal you can open up within the web GUI to interface with your Google Cloud Platform organization. And we're going to utilize our local terminal throughout the course. We may use this occasionally where it's more convenient, but it's nice to have. If you're on a machine where you don't have a terminal configured, or it's a machine you're worried about security, and you just want to work within the framework that Google Cloud is providing, not having to worry about the local environment setting it up, this is a good way to circumvent that. You can just work from the shell. And I can close that here. Okay. And then up here, we can send feedback. We can look for help. And then there is our profile. And we can set preferences, keyboard shortcuts, downloads. We can view cloud partners, terms of service, privacy, project settings, support, some convenient links there as well. Okay, that's all I really want to cover in this lesson, so go ahead and mark it complete and move on to the next. Thank you so much for taking the time, and I'll catch you on the next lesson. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm going to talk to you about the Gcloud CLI tool. Okay, so now that we've set up our Google Cloud SDK in our local dev environment, the Gcloud tool is available for us to use. So it's been added to our path. So I can just type Gcloud and enter, and of course I didn't specify any arguments, so it's complaining about too few arguments, but it gives some suggestions of different arguments you could invoke. And you notice it says group may be. Gcloud has this concept of command groups, and command groups they're based on some release or a component, and then there's some other just subgroups that they can be. So app, for instance, the first one here, it would be the command group for app engine interaction. Auth, as you might guess, would be for authentication. Components would be for SDK components. Compute is for the compute engine and managing compute engine instances, for example. So if I did Gcloud compute and then instances, so we're talking about multiple command groups here. So we have the Gcloud compute command group, and then we have the Gcloud compute instances command group. And then we would say do something like list. Now we don't have any installed or configured to list yet, but that's how we would invoke that. So the list would be the actual command, the compute would be a command group, and the instances would be a command group within that command group. Okay, so you can have nested command groups. All right, so that's one example for something you can do with the CLI tool. So you could actually start a Google Compute resource. You can list components like I mentioned for the various groups, or you could view active projects with the CLI. You can manage the app engine. You can do things with networking like creating a VPC, a virtual private cloud, and you can manage deployments. Okay, so before we get going too far with this, there's a couple of configuration steps I want to do. So first off, we need to configure our Gcloud tool to use our account. So we need to go Gcloud config. So there's the command group for config. And we'll say set account. And then we're going to specify the Google account we're using for Google Cloud. So for me, I'm going to be using LA gcpdemo@gmail.com. So I just set up a Gmail account to do these demonstrations. So I'm going to set that account. All right, it's updated. And I'm going to also set a project. So to start out, I'm going to say gcloud config set project. And I'm going to go back over to my browser. And here on my Google, I'm just going to go to cloud.google.com. And I'm going to sign out of this account. All right. Cloud.google.com. And click on console. And I'm going to choose this lagcpdemo@gmail.com. It's going to ask for your password. I'm going to get logged in. And what I want to get logged in for is so I can see my project ID. So I want to set that from the command line here in my local dev environment. So here it is. So for our first project that got configured, we got a project name and a project ID. So I'm going to grab that and I'm going to paste it in here. I'm going to set it. Okay. So the next command I want to run is in the auth group. So gcloud auth, then log in. All right. And if I press enter, it's going to bring up the browser. It's going to ask me to choose an account. And I'm going to choose that same account. And I will allow. All right. And so now we're authenticated. Very cool. So now that we've authenticated, we can do things with the projects group. So I can say gcloud projects list. And there's our project. We've got our project ID, the name of the project, and a project number. And we can say gcloud projects help. And here are all the options for projects. Help is actually not a valid option here, but it does bring up the usage. And let's just talk through some of these gcloud projects options and commands. So we have some add IAM policies, some various IAM policies. So it's managing permissions and roles for projects you can do from here. There's also the creation, deletion options, and then describe. And we will need our project number, or ID will actually work. And it gives us some brief information about our project. We've got our creation time. We've got the lifecycle state, so it's active as opposed to inactive. Get the name again. Then there's our ID and project number. One cool thing we can do now that we have this interesting output about our project is we can specify a format. So we can do -- format equals JSON, and it will give us a JSON output with the same data. Or we could use YAML. It's useful if you're doing things programmatically. You can have easily parsable data. And it also supports some other formats like CSV or tables. Another useful thing, for each command group, you can actually run help to bring up a man page. So if we do a -- help on projects, we'll have this big man page. And here we have like a description of the commands we might want to run. A lot of IAM policy stuff like I talked about, create, delete. It's pretty limited for projects. Okay. Another command group that we can kind of take a look at now. And as we go forward, I'll show you how to use the Gcloud command line tool for whatever topic we happen to be working on at that point in time. For now, I'm just trying to walk you through, get you comfortable with it, and introduce some of these early concepts that we can take a look at now. So another thing we can look at is components. So components, and let's just do a list for now. So when we run list on components, And I'll scroll up a little bit. Yeah, you can see the version of the SDK that's installed, and we can see the latest version. So there's been a new release since I installed initially. And then we have a table with a list of components that are installed, not installed, or that have an update available. All right, so we see this update's available. So let's go ahead and do that. We can do Gcloud components update. And you may or may not have an update to do. Depends on when you installed initially and when you happen to be going through this exercise. So we'll say yes, continue. It's just listing some information about the update. This might take a few moments. Didn't take too long. Okay, so our update's done. Now let's take another look at our list. So Gcloud components list. See our core libraries is down here and installed it. It's not saying there's an update. It says our current SDK is 154.0.1, and that's the latest. So that looks good. All right. So next I want to show you how to do an install of a component. So let's do a Gcloud components install. And how about kubectl? So that's the CTL for Kubernetes. Let's install that. All right, and here we go. We got our version information. Looks like 1.6.2. And there's a handy link for release notes. We're just going to say yes, enter. All right, so that's how you would install a component. And in order to remove a component, you would just simply do a Gcloud components command group, remove, and then you would specify. So if we wanted to remove kubectl, we would do that. And we'll go ahead and leave it in place, but yeah, you would just say yes and enter, and it would remove it. So we'll just say no, we're gonna leave that. So some other command groups, there is Gcloud Docker, and that provides Docker CLI access to the Google Container Registry that you may have set up for your organization. And Gcloud feedback, and we can do a help on that one. And yeah, so Gcloud feedback, it just allows you to provide feedback for what you're using the SDK for. So I'm going to say 6, none of these. And I don't want to file a bug. Okay. Then there's Gcloud Help, like I had mentioned. And that would just be the man page for the Gcloud CLI tool. It's got everything. It's a big one. Gcloud Info is just going to show the general info for my setup. And here you can see current properties. You see that config information that we went through initially. And then there's some more information here about the installation, about the version of Python that's running. Okay. And then we've got Gcloud version. And it's just going to list all of our versions. All right. So something else I want to show you is it's kind of a new thing. It's an alpha feature, actually. There's a dedicated feature. I'm sorry, a dedicated shell for Google Cloud. And I'll show you how to install that. So it's Gcloud components install alpha. So we're installing the alpha features for this release. Okay. So now, in order to invoke an alpha command group, we actually have to specify alpha, which is a command group in itself. So we'll say Gcloud alpha shell. All right, so the shell is running. And now let's see, let's do a components. And this is pretty nice. So we can do components, and it's got a little helper here, an auto completion. So I can press my down arrow and take that suggestion, just like that. And when I do that, we get our little description of what it does, all right there. So we'll say components, and let's just do a list. All right, so basically you have all the functionality of the Gcloud CLI tool, but without typing the Gcloud, and it's in a dedicated shell, and it's got a lot of helpful little helpers that are pretty useful. So if you're going to be doing a lot of work from the Gcloud tool, you might be interested in using this dedicated shell. Let's take a look at our projects. So projects, and then we'll describe, and we need our project ID once again. So let's just do a list first, and then we can grab that number and describe it. And there you go. You'll notice when I do that describe, YAML is the default format. This is actually YAML. So if I did format YAML, be exactly the same. Okay, so that's all I really want to talk about for the Gcloud CLI tool for now. As I said, we'll as we continue through the lessons, we'll go through the relevant commands in the Gcloud CLI tool that you can run for that particular topic. But for now, I just wanted to give you an overview and show you a few things we could do with this limited setup we have so far. So go ahead and mark this lesson complete and move on to the next. And thank you so much for taking the time. And I'll catch you on the next lesson. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I just want to briefly talk you through projects. So I want to talk to you about what projects are, why we need them, in the greater context of Google Cloud, what is their purpose, okay? All right, so what are projects? Well, all resources deployed in Google Cloud must be associated with a project. So anything you deploy, any type of resource, whether it's a compute instance that we might deploy with a compute engine, or we're utilizing the app engine to deploy a simpler app, or we're using a storage bucket for object storage, everything. Every resource that you deploy with Google Cloud must be associated with a project. And now the scope of a project, it kind of depends on how your organization handles it. But typically you define a project like you would define a project at work. So, you know, if you have a project around a particular piece of software your team is developing, then that would be the project your Google Cloud would correspond with, your Google Cloud project. All right, resources, yeah, projects, in fact, are resources as well, but they contain all resources like I mentioned. And IAM, or identity and access management, can be deployed on the project scope. And in the hierarchy of your project, some IAM permissions will be inherited by the children resources. Okay, so managing projects. You can manage projects a few different ways. You can utilize the Cloud Resource Manager. That's sort of the top level view of your organization in Google Cloud. You can also use the Google Cloud Web Console to do a lot of project configuration, and we'll walk through that process. That's where you would just go to the web console in the browser and click a few buttons and start a project. And then you can also use the Gcloud CLI tool. And here's an example of a command you might run inside of the Gcloud CLI tool. Gcloud projects, and projects would be the command group, list, and this would list all of the active projects in your organization, or at least the projects that you have access to. All right. Project identification. So there's a few different ways to identify your project. When you first create your project, you set at the very least a project ID. And a project ID is important because it must be unique to the world. It's the primary identifier for yourself and for Google for identifying your project and how to manage and configure it as you move forward. And it's required when you configure a project. You must set a project ID. And actually in the web console, you set a project name, which is the next form of identification. So a project name it's created by the user, and it's meant to be user readable. So, you know, it's not like this vertical vel 167.305, some random, like this is a randomly generated ID. Okay. Now, this was generated when I had specified a project that was not unique. So a project name that was not unique. So from the web console, as opposed to setting a project ID, you can set just a name, and then Google Cloud will provide you with a unique project ID. But you can also set your own as long as it's unique. All right. But in this case, my first project is probably not very unique. It's a name a lot of people use to identify like a hello world or first project, just playing around with the console type of project. So Google Cloud will generate an ID for you. And then when you create a project, you also get a project number. So this is generated at the time of project creation, and it's a number like so. And you can also use the number oftentimes to identify your project when you're utilizing like the Gcloud CLI tool, for instance. In the case of the Gcloud CLI tool, you can specify or identify a project via the number or the project ID. And that's typically what you would do. You wouldn't use the project name in that case. So really a project name is just for the context of identifying your project within your team. It's just an easy, human readable name. All right, so that's really all I want to talk about with projects as far as projects go. Just it's important to know that projects, they have their own identity and access management, and they're used to contain all of the other resources. And all resources have to be associated with a project. So those are the important points to remember going forward. All right, well, that's all I want to talk about. So go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I just want to talk to you a little bit about Google Cloud IAM, or Identity and Access Management. Okay, so Google Cloud Identity and Access Management. What is it? Why is it important? Well, Google Cloud IAM allows the management of who has which access to resources in your Google Cloud environment. So there's similar concepts in other cloud providers like AWS. It's actually called the same thing in AWS, IAM. it's what's used to manage what users can see what users can perform what actions on what resources in Google Cloud. Okay, and here's a little diagram about IAM and how it works. So you basically enforce these permissions through policy, and a policy is comprised of both roles and identity. Okay, and roles are predefined. As you can see our examples here, roles are predefined for the different resource types. So for compute instance admin, there are a set of permissions that can be performed on a compute resource. And the same for storage and app engine and logging. All right, so for logging.viewer, that particular role can view logs, and that's probably about it. Now, identity is how IAM determines who you are. So Google Cloud or Google Cloud accounts, Google accounts, are what you would think of when you think of like a Gmail account, like your user account for Google. That's a Google account. It's a standard account. A service account is it's an account associated with a process or a resource, and I'll talk a little bit more about that later. A group it's just a group of users, and an apps domain is like if your organization has a Google Apps account, a business account, then you would be all a part of that domain. All right, so that it's a way of identifying. Okay, so cloud IAM policies. Roles are granted to users based on IAM policies. And here's an example of the IAM policy for a project. All right, and you notice that these bindings here, so they're listed as bindings when you look at an IAM policy. And this is actually a command invoked from the Gcloud CLI tool, so it makes it pretty easy to get an IAM policy for a resource. So within the projects command group, you can run git IAM policy on a project, and this is my project ID, and it will give you all of the permissions bindings. All right, so you'll notice there's a bunch of service accounts here listed as editor. All right, so these all have the role of editor, and they're assigned to these users. So if I go back to the previous slide, identity. So these are identities, and then this is a role being assigned to these identities. And down here is probably the most simple case. This is the account I've used to establish my project, so it's inherently owner. So it receives the owner role. So my user is an owner. And owners can do just about anything within your Google Cloud project. So it's the most powerful role. Right? All right, so there are two types of access when we talk about access provided by identity. You have member access, and again, we've gone through this list. It was in the diagram. It's a Google account or a service account, a Google group or a G Suite domain. It's how you would be determined who this person is or this user is. I should say account because service account isn't associated with an actual physical user. And then we have non-member access. So you can actually provide access to non-members. And the first one is all authenticated users. And these would be people that can log into Google, but not necessarily into your project. They don't have specific permissions within your project, but they're logged in via Google. That's an authenticated user that isn't necessarily associated with the project. And then you have all users. So this would mean that anyone that's not even authenticated, anyone who has access to your resource in some manner can operate on it. All right. Now roles. Roles are basically just a collection of permissions. That's really all there is to it. That's what a role is. So, and there's two types. There's primitive and predefined. Primitive roles, they're common, very basic permission sets. So like I just mentioned, we just looked at a user in the bindings for a project, and we saw editor and owner. So a viewer, the first one there, is someone that can view a resource. So I can run the Gcloud CLI tool as this user if I have the viewer role and I can view it, but I can't edit it. And that's what an editor could do. I could change it. I could view and change. And an owner, like I mentioned, it's the most powerful primitive role. I can do pretty much anything to a resource. Anything within my project if I'm a project owner. And these can be set at the resource level as well, so it doesn't have to just be a project or a project scope. All right, we also have predefined roles, and these roles are resource-based, provided by Google Cloud automatically. So they're predefined. Whenever I stand up some resource, like for instance, compute, and I'll get into examples in a minute, but if I stood up compute, it comes with a set of resource-based roles that I can assign to identities or users. Okay, so the syntax for defining a role or for accessing or granting a role is resource.role. So the name of the resource, and here's an example for compute engine. So the resource would be compute in this first example, and then you would have a network admin role, and that comes with a set of permissions. As I mentioned, a role is basically just a set of permissions. All right, so we have a network admin that would be able to do all the administration for networking tasks on a compute instance. Then we have security, which would be able to perform all of the security administration tasks. So like setting SSH keys or firewall rules, for instance. Networking would be able to set up networks and subnets, virtual private clouds, things of that nature. And image user would be able to would be able to access images in compute. Okay. So this is just an example. There are so many resources provided by Google Cloud. It's not reasonable to go through all of them here, so I just have this compute example, but every resource has predefined roles. There's so many. There's hundreds to thousands. There's a ton. All right, so resource-based permissions. And yeah, here's your basic cloud resource types. And there's, like I mentioned, there's so many more. There's projects, compute engine, cloud storage. There's app engine instances. There's big data associated resources, just about anything you can think of, networking. So resource-based permission syntax. So we've talked about roles, and let's take a look here. All right, so we talked about a role. So compute would be the service being provided. Instances would be the resource within the service, or if you compared it to a Gcloud CLI tool invocation, it would be a command group. So it would be kind of like a one-to-one there. Compute, instances, and delete. So if I have this particular permission, and this permission is part of a subset of roles, resource roles, I could delete instances in compute. So I could delete a compute VM with this permission. And it's the same deal with get and list. I would be able to get or list a permission or an instance from within the compute engine. All right, service accounts. So I mentioned this briefly. These are non-human accounts, so that they belong to a VM or an application as opposed to a typical human user. So there's not necessarily a Google account associated with these service accounts. Well, it is a Google account, but not like a Gmail account. It's something that would be associated with a human user. So there's two types. There's user managed accounts and Google managed accounts. So a user managed account, it's created implicitly when a resource is created. So if we look at our example here, this particular service account was created when I instantiated a Google Compute Engine resource. So this is a resource associated with that Compute Engine resource. Okay, so when we think about what this user might do, we think about what operations we might want to run on our Google Cloud project from within this Compute Engine resource. Okay, so that's what we think about there. So now Google managed accounts, there are accounts that are created and owned by Google. So any kind of dynamic, and in here we have a comparison in the syntax here. So we have a Google managed service account here, and then we have a service account for the container registry. All right, and these are accounts that are utilized to perform administration that's provided by Google inherently. All right, so any kind of operations that Google needs to perform on your resources, they use these accounts. All right, and we don't have control over these accounts. Access scopes. Okay, so when we create a resource in Google Cloud, and when we instantiate a resource, remember there is automatically a service account oftentimes associated with that resource. Okay, so when we set access scopes, we set a set of permissions for the resource, and those permissions are inherently assigned to the service account associated with the resource. All right, so for example, let's take a look. We've got this service account, so we've instantiated a VM with the Compute Engine, and it's been assigned this service account. All right, and here I have a Gcloud compute command. It's kind of a long one, but the bulk of this is setting access scopes. All right, so I just want to walk through those. All right, so we're instantiating this VM, and we're giving it compute read-write service control. So if you look here, you've got compute read-write, service control, service management, logging right, monitoring right, storage RO, and then we've got trace append and source full control. Okay, so you can actually, if you don't have a shorthand version of an access scope, you can specify the API endpoint directly, and it will determine it dynamically. So it's pretty cool. So this one is a relatively new one. There's not a shorthand for it. It's for access to source control repositories or source code repositories. Okay. So by instantiating the compute instance and specifying these scopes, our service account can now perform all of these actions associated with these permissions. So it's pretty cool. Something to keep in mind when you create a resource, because with some resource types, you can't go back and change these scopes through access scope anyway. You may have to do some IAM configuration to do it retroactively, but this makes it nice and easy to establish permissions from the beginning. Okay. All right, so that's all I really want to talk about with Google Cloud IAM, Identity and Access Management. Just the most important thing I think from this lesson is resources all have predefined roles and permissions, and keep that in mind when you're setting up your architecture and when you're setting up access scopes as you instantiate instances. And also keep in mind about the primitive roles and ensuring that your human users have appropriate roles. And that's all I really want to talk about. So thank you so much for taking the time. Go ahead and mark this lesson complete, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm just going to talk to you a little bit about creating and managing projects. Okay, so here I am. I'm at cloud.google.com, and I'm just going to click up here on the console. In this lesson, I'm going to show you a couple different ways to add projects, and then I'm going to show you a few interesting things about managing projects from the CLI and the console. Okay, so here we are, and this is the dashboard we talked about earlier, and a basic view. And if we look up at the top left, we see my first project here. All right, so we're currently have a project selected. Now, what I want to do first is add a project using the web console. And all you do is, I'm going to cancel that. You'll click this little down arrow. And then we're going to click the plus button. All right. And now I'm going to name our project. And here's what I want you to do. I want you to name it, this time, we're going to call it cat time space. Actually, let's call it cat time space Node.js, and then I want you to use your Linux Academy username. So I'm going to use mine here. It's Brandon423. All right, and as long as the project name is unique, your ID will be the exact same thing but lowercase with spaces replaced with dashes, right? And I think that's a good way to go because you'll have a project ID that you can remember. Okay. And we'll talk a little bit more about what cat time is in a future lesson, a couple of future lessons. But for now, let's just call it that. All right. And we'll create it. And this takes a few moments. Because if we can look, we're still on the My First Project when we after we click create. You'll notice the notification bubble up here with the circling that indicates that something's happening. So now let's click on our notifications, create project, cat time Node.js Brandon423. We can click in here. All right, so I just changed projects by clicking on that notification. You can also do it by clicking up here again, and either in recent or all. And if I hadn't clicked from the notification, it wouldn't be showing up in recent, right? It would only show in all. So if you click up here and you notice your project isn't listed right away, it may be under the all tab as opposed to recent because it hadn't been opened at that point in time. Okay. So that's how you do that. So now we have a new project. I'll cancel that because it's already open. And we have our project info here. We've got the name, the ID, which corresponds to the name exactly, except spaces are replaced with dashes and it's all lowercase. And then we've also been assigned a project number, which we can also reference the project as. All right, so now let's go to the terminal. And I want to create one other project. So we're gonna deploy a couple of projects later on with the App Engine, and they're identical except for the language they're written in, and so they'll require slightly different requirements when provisioned by the App Engine. So we have one more project to create. All right, and I'm going to show you how to do that with the Gcloud CLI tool. Okay. So we've got our terminal open, and I'm just going to type Gcloud, and then we need to go to the projects command group. And if you remember from the previous lesson when I talked about Gcloud specifically, you can do a Gcloud projects list, and you'll see our new project is there now. We see cat time Node.js Brandon423. We also see my first project. Okay. So another thing we can do in the projects command group is create projects. So let's do a Gcloud projects create, and then I want to specify a name. So I'm going to say -- name, and this isn't a required parameter. If you don't pass a name, it will use your ID as the name. So I'm going to call it cat time, and this time Sinatra. So we're going to be provisioning this application with Node.js, with it built in Node.js, and with it built in Sinatra. So cat time Sinatra, and that's a Ruby-based framework. And then I'm also going to specify my Linux Academy username, Brandon423, and close the quote, space, and now I'm going to specify a project ID, and that's just going to be cat time Sinatra, Brandon423, just like that. So when you create yours, if you're following along, use the same form. Say cat time -Sinatra -your Linux Academy username, and the same before on the web console. All right, so let's create that. All right, and this might take a couple moments. Okay, and it's all done now. So let's take a look, and let's go ahead and look at our list of projects now. So Gcloud projects list, and it should be there now. Okay, so it's here, and we've got our assigned project number. Okay, and then let's take a look at Gcloud projects describe and cat time dash. We'll look at the Node.js, Brandon423. And there we go. So there's our describe output for projects, for the projects command group. All right, now I want to illustrate how you can actually remove a project. So we no longer need this my first project. We used it for a couple demonstration purposes, but other than that, we're not going to do anything with it. So let's go ahead and remove that. And that looks like Gcloud projects delete, and then we specify either the project ID or the project number. So I've got the number here, so I'm going to copy that and paste it in. All right, and we'll go ahead and delete that, and it'll ask for a confirmation. And notice it doesn't tell you which project it is, so you want to make sure you grab the right number. Now, I'm sure it's right here in front of me, so it's a good idea to look at the list, verify, because it doesn't say, are you sure you want to delete this particular project? It just says, do you want to continue? So you want to make sure you got the right number. So I'll say yes. And to avoid the possible confusion, you could use the project ID, which might be a better practice, but we'll just use the number for now. So we'll remove that. Okay. And for a limited period of time, you can actually undelete the project. So if we do Gcloud projects list, it won't be there anymore. Right? It's gone. But if I quickly did a Gcloud projects undelete, Gcloud projects undelete, all right, so it's restored now. So if we go back up to project list, there it is. So they kind of dummy-proof things a little bit for us. So that's nice. Anyway, we want to remove it, so let's go ahead and do that again. Okay, so now one last time, Gcloud projects list, it's gone. We've got the two projects we need to move on in the course. Okay. Another thing I want to show you, Just a couple other CLI commands you can run that are kind of useful. You can do a Gcloud projects and then git im policy, and then you can specify, this time let's do it for the Sinatra project, Brandon 423. Okay, just like that, and it will return the output and the bindings for the permissions on this particular project. And right now I'm the only user, so this Gmail account that I set up for all of these demonstrations is shown as the user. So as we move forward, you'll notice, and we'll check in as we deploy things, you'll notice service accounts will be dynamically created, and you'll see some permissions when we look at the IAM policy. If I had a more diverse organization than myself, I could add users and they could have certain permissions, and we could apply different permissions to different resources within our infrastructure. But for now, it's just me. So I just wanted to show you, you can pull in that policy easily from the Gcloud CLI tool. All right, now let's go back to our web console and let's see if our new project's there yet. So let's click our drop down, click on all, and there it is. Okay, so there can be a bit of a delay in when your new project will actually show up in the web console when you add it via the Gcloud CLI tool. But here it is now, so I can click it and move into that particular project. And it's empty at the moment, but that's how I would do that. Now I could go into the IAM and admin. And we can see the permissions for the project. And right now, see, so it's just a different representation of what I showed you here from the command line. Okay, it's got one user in the organization, and it's the role of owner. Now I could drop it down, and I could set permissions based on resources. So I could say, you know, this user myself is only an editor, or someone might be a viewer, or a service account actor. So it's the same set of permissions for a lot of these. Yeah, App Engine Admin, Code Viewer, Deployer. Okay. So there's a lot of different options within a project, because that's one of the larger scoped resources is projects. So within a project, you can set roles for each individual type of resource. All right. Well, that's all I really want to talk about with creating and managing projects. So go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm just going to talk a little bit about the Google Cloud App Engine. All right, so what is the Google Cloud App Engine? Well, the App Engine, it basically, it's a platform for applications that completely abstracts away infrastructure. All right, it almost completely abstracts away any thoughts about infrastructure when you're using the Google Cloud App Engine to deploy your application. Their ideal here, or mission, is to just add the code and go. So it's designed for the developer that doesn't want to have to deal with much infrastructure directly, but they want the advantages of a distributed, robust infrastructure. And that's who it's designed for. They can just add the code and go, and they get features like auto scaling and resiliency and geo distribution. All of this stuff's kind of natively built into the App Engine. So features, I've talked about them a little bit. It's a microservice behavior. So it behaves like a kind of a microservice. You're not concerned with the state of the system or the physical system that it's on. You're not concerned with managing that. It's kind of ephemeral, so it can go up and down, but you're basically not concerned about a particular instance that this service is running on, right? It's distributed. It exhibits this microservice type behavior. It automatically handles issues of scale, so it can auto scale. There's two types of scaling actually with the App Engine. There's manual and automatic. With manual scaling, you can scale continuously to the exact number of instances without consideration of the load on the system. And auto scaling is it's based on the request rate, response latency, and other app metrics. Okay, and it's also got built-in load balancing to offload requests between instances. It's got native auth and SQL support. It's got inherent instance management. So it's got health checks of your instances, of your compute instances. It's got backwards compatible updates. So a lot of the App Engine instances are actually supported by Google Cloud. So if there's some important security update out there, like for instance, like a couple of years ago with Heartbleed and OpenSSL, it would provide those updates in a backwards any kind of backwards compatible updates automatically to your App Engine instances. It also handles issues of geo allocation, so it's going to distribute your application and it's going to try to minimize latency by serving requests closest in proximity as much as possible. And it's got some integrated logging, which is nice. So you can log through just writing to standard error and standard out, and then that will in turn be integrated with the logging service from the web console. All right. And yeah, there are two types of App Engine environments. There's flexible and standard. And then first I'm going to talk about flexible. So the flexible App Engine environment allows for the customization of your runtime. And you can even modify your runtime using Docker files. It allows you to use a more flexible code set that doesn't have to meet strict standards in how it's laid out. You can specify how your application starts. You can make HTTP requests that aren't necessarily through a Google Cloud API. It allows for just more integrations outside of the context of Google Cloud. And there are more runtimes for the flexible environment. You've got Java, Python, Node.js, Ruby, PHP, .NET, and Go, and there are fewer for the standard environment. Okay, so the App Engine standard environment. It's a more standardized environment. It doesn't allow for as much customization, but it supports more SDK functionality natively. So you're kind of trading flexibility for consistency and actually more support and more integration. So you're more tightly coupled to the Google Cloud infrastructure, but you're also gaining the advantage there. You're standardizing, you're kind of future-proofing a little bit, and you're taking advantage of a standardized environment that's got the support of Google behind it. But like I mentioned previously, it doesn't allow for arbitrary network connections, file system access, or native code. It's dependent on the use of APIs for management, so the use of the Google Cloud service options. And it can be more cost effective for inconsistent loads than a flexible environment. All right. And there are fewer runtimes. So there's only runtimes for Java, Python, PHP, and Go in the standard environment. All right, app.yaml in several languages with runtimes within the Google Cloud App Engine. You'll utilize an app.yaml file for configuration. And in the two flexible environment examples that we'll go through, we're going to be utilizing the app.yaml, and that will be for Node.js and Ruby. So here's it's the primary configuration that lives in your source code management repo, and parameters vary based on the runtime. So you'll find different options and parameters between runtimes for your App Engine configuration. So I've got a sample, like a very short sample file, configuration file that we'll actually use to deploy one of our applications. And the first option here is runtime. It just says Ruby. and you would substitute in the runtime that you desire for your application to run here. So if you wanted Java or Node.js or Python, you would specify that here at runtime, and that would be the runtime you would get. env is specifying the type of environment, so we're specifying flex as opposed to standard. If we wanted to use a standard environment, we would specify standard. Of course, there is no Ruby runtime for the standard environment, so that's not an option for us for this particular application. And then we have the entry point, which is the command that's run to actually start the application. So it's bundle exec rackup -p 8080. So that's initiating a rack-based application on port 8080. And 8080 is the port that actually corresponds to the 443 HTTPS port that's abstracted from the application that the URL that's provided by the app engine will point to. So it's kind of presents as an abstraction. It's like a load balancer basically, where it's standing in front of your instance running the application, and it says, okay, I'm a 443 and I'm going to point to 8080 on my application running instance. So that's the app.yaml. This is the basic configuration, and we'll get more into it obviously as we start applying it, but I just want to get you somewhat familiar with the app engine and some basic configuration. Okay, well, that's all I wanted to talk about for the app engine for this quick little intro. So go ahead and mark this lesson complete and move on to the next, and let's start using it. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I just want to walk you briefly through the web application that we're going to be deploying as a demonstration of the different components in Google Cloud. So here is the site where for the project on GitHub. It's called Content GCP Essentials Cat Time Node.js. And I'll post the link in the description for this video, but here it is. And I've got it checked out in my local environment. And so I just want to walk you through some of the major components. First off, let me show you what it's going to look like. Here's the provisioned website. It's a very basic application. We're utilizing Express and Node.js for a minimal backend. There's some JavaScript to utilize on the front end to load new pictures, basically. So if I click try another, we'll get a new cat or a set of cats as shown here. Express is a very lightweight framework for Node.js. This is really just to demonstrate how to provision an application, a JavaScript application with Google Cloud. All right. So what the application does, it's called Cat Time, and we have the aim of promoting general well-being through the use of cat-related media. And so it's asking you here, are you feeling sad? And here's a cat, and the goal is to make you feel better by showing you cute pictures of cats. We can load up the cats, get a new picture just by clicking here, try another. All right, and it utilizes the catapi.com. So I'll show you that real quickly. It's a very simple API a lot of people use for these types of demonstrations, demonstrating API use and things of that nature. So they provide this API where it returns image URLs for cats. So that's all we're doing. We're loading up images of cats from the cat API. All right, and now going back to the project. Here we have some pretty basic HTML. I won't walk you through all of this. It's not all that interesting. We're loading up Bootstrap for some styling, also some custom CSS, and a font for the header from Google APIs, and a little JavaScript. And first, let's take a look at the custom styling. So just some custom styling here. Throws in that color scheme and the layout that we want. And then we've got some custom JavaScript here. So I'll load that up. All right, so this first function is just calling the API, returning, we're asking for XML format, and then we're parsing XML and grabbing the URL from that. That's what this get_a_cat function does. And then we have this update pick function, which is called, and it's actually updating the tag with cat pick with the URL returned from get_a_cat, and it's changing the source. So if I go back to our index.html, you'll see source here. So this gets updated every time that button is clicked, right? So here's the button in the HTML, and whenever it's clicked, we're calling that function update pick. So that's how it works. That's the primary functionality there. Now I'll jump into the app.js, and here we're requiring Express. It's that framework I talked about earlier, and it's real simple. We're just loading it up. We're using a static public directory, so it's really just loading up what would be a traditional website in this public directory, and we're listening on port 8080 by default. So that's all that's doing. Now the app.yaml file, it's a Google Cloud configuration file, and we're just saying we're going to use the runtime Node.js, and we're going to use a Flex environment. And I'll talk a little bit about Flex versus standard environments when we really dive into the app engine, but for now, it just means it's a flexible environment, and it's catered to more types of applications than the standard. So that's what that is. And we have package.json. We really just got the one dependency to install Express, and there's some information about the application here as well. So that's really all there is there. Now, just to demonstrate how this works and how you can run it locally, let's do that really quickly. Okay, so I'm just going to walk you through running this locally so we can test it out. All right, and so I'm here on a Linux Mint local dev environment, and I've got their repository checked out. And so just to walk you through that process, you can grab either from the documentation associated with this, or from this site, you can grab the clonable link right here, Git Clone. So I could grab that, and I would simply, maybe from my home directory, Git Clone, like that. Okay, so that's how you would go about cloning the repository. All right, so I'm just going to move back into it. All right, so here we are. Now, I'm going to sudo to root. And then I'm going to make sure I have curl and Python software properties installed. So I'm going to install those. All right, so I've already got them. And then I'm going to run the installer from the node source site. So I'm just going to copy and paste this in. Okay, that's the command. And it's going to do some setup. We'll set up our sources for the install. All right, and then we do an apt-get install Node.js as the root user again. All right, and let's check our version. So we should have Node version 7, I believe now, 7.10.0. Okay, good. And we'll do an npm version, and npm is the package manager for Node. Okay, So that looks good. All right, and we're in the root of our project repository. So what we want to do is install with npm install. What that is doing is it's looking at this package.json file, and it's going through the necessary steps to install the dependencies and the required packages. So I'm going to run that now. All right. And yeah, we've got a couple of warnings, but these aren't any big deal. We're just lacking a couple of fields that are typically seen in a package.json, so it's okay. And then we need an npm start. All right, and now I should be able to go to my browser, and remember we're configured for port 8080, so I should see a local host 8080. Should see our site, and there it is. All right, we got some cats. So very cool. All right, well, that's all I wanted to talk to you about for the app. And I just wanted you to be familiar with kind of how the app was built without getting too deep into it because it's not the focus of the course. But yeah, I just wanted to get you familiar with the site and show you what we're deploying. So go ahead and mark this lesson complete and move on to the next. Thanks so much for taking the time, and bye for now. All right, and it lists some of our current options in our Gcloud configuration. We have our compute regions and the account, usage reporting, and a project ID. All right, so we're currently, this particular project by default is configured for the active configuration of default. All right, so what we want to do, we're going to create a new configuration. So we're going to type number 2. And for configuration name, we're just going to call it, let's say, give it cat time Node.js all right, and then you can choose, if you have more than one account, you want to choose the account for this particular project. So choose 3 for my demonstration Google account. And then I've got my 2 projects here, the ones we configured previously. So I've got cattime Node.js and cattime Sinatra. And you'll have the same, but you'll substitute your Linux Academy username for where you see mine there, Brandon423. Select number 1. All right, and it says the API for compute, or compute component, is not enabled on this project. Would you like to enable and retry? So we're going to click yes. So Y, enter. So that's enabling the compute component. And if we went into Google Cloud right now, okay, there it is. There's our uptick in our API requests. All right, so that's completed now. Do you want to configure Google Compute Engine? We're going to say yes. And here we want to specify our default zone for this project. So there's a long list here. There's looks like 24 or 23 different options. We want to choose one of Europe West, US Central, US East 1, and Asia Northeast 1. So I'm going to choose the one that's closest in proximity to me. So I will choose US Central. And the reason we want to choose one of those, and we'll just go with A. So I'll choose 14. The reason we want to choose one of those is because the app engine is only available in those 4 sets of zones. So you'll just want to choose the one that's closest in proximity to yourself. Okay, and now our SDK is ready to use for the project. And we've got this cattime Node.js configuration. that's associated with it. Now, as a reminder, I just want to hop in and take a look at app.yaml. So cat app.yaml. And we've got Node.js specified as the runtime. And the environment type is Flex. All right, so the runtime just means I'm running a Node.js application. And the env just means I'm using a flex environment, a flexible environment, as opposed to a standard pre-configured environment. Now we're ready to deploy the application. So we can do a Gcloud app deploy. That's all there is to it. And then we're going to choose an app engine. So I'm going to choose US Central again, number 2. And we're creating an app engine application in project cattime Node.js Brandon 423 in my region. And you'll see the same, except substitute your Linux Academy username and your region. All right. Here's a little information here. You're about to deploy the following services. So we've got our application here, and we're deploying it to this URL. So once it's deployed, we'll be able to reach the application at this URL. And notice it's HTTPS. So 8080 by default for a Google Cloud App Engine app will map the port 8080 to 443, which is the standard HTTPS port. All right, so we want to go with yes, enter. And this takes quite a while, so it could take several minutes. So I'll go ahead and pause it here and catch up when it's done. Okay, so it's showing that our app is deployed now. Let's scroll up and look at some of this output though. Let me make this full screen. All right, we'll scroll up to where we left off. And that's gonna be right, yes. So it says, do you want to continue? Yes. All right, this is where we left off. Okay, so we're deploying the service, building and pushing an image for the service. Okay. Now, one thing to note, we're using a flexible app engine runtime. So that actually happens inside of a Docker container. So we're actually utilizing the Google Cloud Container Engine that's abstracted by the app engine. So underneath, it's actually, this application is being deployed via Docker and the Google Cloud Container Engine, which is kind of cool. Now, if we used a standard environment, it would use a proprietary runtime environment that App Engine was limited to previously before Flex became available. But yeah, this is actually running inside of a Docker container. So you notice it's pulling this Node.js latest image, and that's actually a Docker image that we're running in. And if you scroll down, we're running install node, and so we're installing node. Scrolling down now, npm install is run, so it's taking a look at our packages.json, and it's installing the specified packages and all their dependencies. So all these get installed. And then finally, within the container, npm start is run, and then that's what actually starts up our application. All right, so that's successful in the intermediate container. So it goes ahead and pushes it over to our production environment, and that's what all this is. It's threaded, it's pushing. And updating service, deployed service, so it shows the URL where our application is deployed to. And it notes here you can actually tail the logs, so we could do that now. We could do a Gcloud. It's in the app command group. Within the logs command group, we can tail-s default, service default. So here you get some log output. That can be kind of handy. And then we can also get to the browser and view our application by doing a Gcloud app browse. or we could just go to this URL. But we'll try out the command line. So we'll run that. So it brings up Firefox, and here is our deployed application. Cat time node.js brandon423.appspot.com. Appspot is the default domain for App Engine deployed applications. And like I said, it's running on 443, the default HTTPS. That's mapping to 8080 on the container side. So another thing we can look at. So notice the uptick in API requests. Oh, we need to go down to container registry. It's down here. Okay, and now we can actually see within the App Engine default. Okay, here is a container that's running in our environment. It's 171.9 megabytes. It's uploaded 55 minutes ago, and it's got the tag of latest. All right, so when you use a Flex App Engine runtime, we're going to get a corresponding container in the registry under the App Engine folder. All right, so we'll see that in here. All right, and once we deploy the other version of the application, we'll see the same thing. We'll just see another instance under App Engine in here. All right, let's go back to our project page, and then if we scroll down, or I'm sorry, up, we click on App Engine. We now see a summary here, and we've got our billing status for this particular application. Hasn't really done much so far, so nothing billable yet. Also, we've got that $300 free trial credit, so no charges yet and no errors reported. Okay. All right, so that's all I really want to talk about with deploying our Node.js application. So thank you for taking the time, and go ahead and mark this lesson complete, and I'll catch you on the next one. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson we're going to talk a little bit about the Sinatra version of our web application. Okay, so you see here I've got our project repo open, and I'm going to go ahead and clone this down to my local environment. So I'm going to grab this link, and I'm going to go over to my terminal, and I'm going to say Git Clone, paste that in. All right, and I'll include the URL, the clonable link, and also the project URL in the description for the video, so you'll be able to grab it from there. But now I'm just going to clone it. Okay, and now I'm going to go into that directory, the project repo directory, and let's take a look at the files in there. So I'm going to open it up with Atom. Okay, and let's close some of these tabs we don't need. All right, first off, let's just look at the gem file. So the gem file is where we specify the gems we want to install as dependencies for the project. So the gems provide compartmentalized functionality in Ruby code, and gems are the concept of a package in Ruby land. So here we are. This first line, we're just specifying a source, and rubygems.org is the default repository for Ruby gems. We're specifying a version of Ruby 2.3.3. That happens to be the current version for the App Engine in Google Cloud, so that's why we're specifying that there. We're specifying the gem rack, and rack's it's a lightweight framework used to deploy a lot of basic Ruby-based web applications. And then we have Sinatra, that's our Ruby-based DSL for the application. And then we have Cat API. So Cat API is a gem, and let's see, let me show you. It's this gem here, and it provides Ruby functionality for accessing the cat API. And the cat API, as I talked about on the Node.js project, it's a publicly available API that provides cat image URLs. So this cat API gem makes it a lot easier to interface with the cat API from Ruby code. Bring that up. All right, so that's all the gems. That's a gem file. That's all that's happening there. All right. And if we go into views, we have an index ERB. So the primary components for a Sinatra project are generally templates and then the actual application code. So this time we have this template for the index ERB, and it's a single page web application. So all the HTML is in here. And we kind of went through it a little bit in the Node.js version of the application. It's pretty much exactly the same, except for a couple of differences: the mechanism for how the button works, and the mechanism that pulls in the URL for cat pics. So you can see here, this is typical ERB template interpolation. So basically, it's resolving this variable called cat pic, and it's going to interpolate it into this image tag on the source attribute. All right, so it's going to place a URL there, and the button just reloads the page. So every time we reload the page, we get a new cat pic. That's what's happening there. All right, and then if we go down, let's see. Let's look at the app RB. All right, it's a very simple Sinatra app. We're setting a port. It's 8080. This git slash. We're specifying what happens when this page loads, and that's just the home page. So that's the equivalent of if we run it locally, like we will a little bit later. Just looking at localhost and port 8080 and then slash, or just the home page. And we're specifying that variable that gets interpolated over here. This one here. It's right here. So we're setting that variable, and it's in the scope of that page. And we are calling getACat, which is this function right here. So in getACat, we're loading up the cat API, and we're retrieving an image. That's what this does. And then the function returns the URL. So we're specifying the cat pic URL here to this variable that becomes available in the template, and it's assigned. And ERB index just says I'm loading this index.erb. So this syntax :index, it correlates to views, and then it's looking for an ERB template called index, and it's loading that on this page access. Okay, so that's about all there is to the Sinatra app. It's very simple. App.yaml, that's a Google Cloud configuration file, and the runtime is Ruby because we got a Ruby-based application. Environment is Flex. So Flex, it's like the name might imply, it's a little more flexible than a standard environment. There's not actually a standard environment for Ruby-based applications right now. So you'll see them for Java and Python and a couple other languages, but we're going to use Flex here. And entry point is the command that we run to actually start up the application. So it's just a bundle exec rackup, and then we're specifying the port again, port 8080. Okay, and 8080's it's the default port for Google Cloud apps, so it makes 8080 is going to map to port 443 when we stand up this application with the App Engine. So that's all that's happening there. Config.ru is the rack configuration. All right, so bundler require just requires all of the gems that are specified in our gem file automatically. We're requiring Ruby gems and bundler here. Require app.rb is the actual application, and then run cat time. If we go up and we look at our app.rb, you'll see the class is called cat time. So we're just running the class, in which stands up our website. Okay. So that's all there really is to the application. So let's run this locally. let's see, it's a good practice to run things locally before you deploy to Google Cloud in general. So let's do that. All right, and what we need to do first is set up Rvm, because we're going to be working with multiple versions of Ruby in our environment. Well, we likely are. I think, let's see, let's take a look at our current version on this system. All right, 2.3.1. So we were looking for 2.3.3. So we want to install Rvm Ruby version manager so we can have multiple different versions of Ruby on our dev system. All right, so let's do that now. And the first step we need to do, and this is based on the instructions on this website, I'll show you. And if we go back to the browser and I'll plug that in, it's on the Rvm installation page. So we're just going to load up this key here. All right, so grabbing the key. All right, good. So I had the key already, but that's how you would pull it down. And then next step, I'm going to install Rvm based on their bash script. So this is how you call it. So it's running, it's piping curl to bash, pulling their script latest stable. So I'm going to execute that. All right, and it'll only be in this user's path, and that's okay for now. If you see this being installed to some other path instead of home, your user.rvm, you might have issues going forward. So you want to make sure you don't use sudo when you run the installer. Just run it as your typical dev user. All right, and this takes a while, so I'm probably going to pause here for a moment, and once this is done, I'll start back up again. Okay, so we've got a Ruby version manager installed, Rvm, and it installed the latest stable version, which happens to be 2.4.0. We need 2.3.3 to fully replicate the Google Cloud environment that we're going to be deploying in. So let's install that. So Rvm install 2.3.3. That's the general way to install individual Rubies within your Ruby version manager. So let's do that. Well, yeah, I need to exit here and open up a new terminal to load up my to ensure that Rvm's in my path. So rvm install 2.3.3. Okay. And again, this is going to take a while, so I'll go ahead and check out here and start back up once it's installed. Okay, so we've got Ruby 2.3.3 installed now. So let's specify it to be used. So Rvm use 2.3.3. Okay, so we're now using Ruby 2.3.3. Now I'm going to move into the project repo and Sinatra. Okay, and now I'm going to run gem install bundler. So we need the bundler gem. And then once we have bundler, we'll be able to run bundle install to install all the required gems for the application. So bundle install. All right, it'll automatically pull in all the dependencies. So there's quite a few. Okay, so we've got our dependency gems installed. And now we're ready to actually start up the application. So it's a bundle exec. It's just like that entry point piece of configuration. So if we look at app.yaml, you'll see entry point bundle exec rackup -p 8080. So that we're going to run the exact same command in our local environment. Bundle exec rackup -p 8080. All right, so it's running. WebRick. It's a very lightweight web server. Utilizing WebRick, we're going to open up and we can go to localhost 8080 and we'll see the application running. There it is. We can click, we can load up, we got more cats. All right, so that's all I want to cover for the Sinatra version of the application, and just going through an overview, showing you what it is, and running it locally. And so now we'll get into actually deploying these applications, or this application, with Google Cloud. So that's all I want to talk about for this lesson, though. So go ahead and mark it complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I want to walk you through the provisioning of the Sinatra web app. Okay, so we've gone through the Node.js deployment, so this is going to be very similar. I'll go through a little bit faster this time, but if you remember, we first went into the repository, so content, GCP, and Sinatra this time. Okay. And here's our repository. And let's take a look at app.yaml. All right, so it's we talked a little bit about this as we went through the repository and all the files in there, but we're utilizing a Ruby runtime because the application is Ruby. Again, it's a Flex environment, and as I mentioned in the Node.js deployment video, Flex indicates that it's actually utilizing a container in the container engine, so it's actually running in a Docker container. And entry point, since our application startup isn't the standard for a Ruby runtime, if you remember back to the Node.js deployment, I didn't specify an entry point. That's because it was a simple npm start and it had all the default layout. In this case, we want to execute bundle exec rackup -p 8080. So we're executing rackup on port 8080. All right, so let's do our Gcloud init. Okay, and if we look now, notice our project is set to the Node.js project. Also, our region and zone is central, as we expect. Same account. So, okay, that all looks okay. All right, so let's create a new configuration for the Sinatra app. So we'll create a new one, and then we'll say cat time -Sinatra. All right, and I'm going to choose that same demo account, so lagcpdemo@gmail.com. You'll want to choose your account here, the account that you're working with in Google. All right, and this time I'm going to select the project I'm going to use. So we're working with the Sinatra app, so I'm going to use the cat time Sinatra Brandon 423 project. And you'll do the same, but you'll want to substitute your Linux Academy username. All right, and we're going to go ahead and enable compute on this project. Okay, so our SDK is ready to use. All right, so the next thing we want to do is deploy the application. So it's Gcloud app deploy, if you remember. It's the same process we did with the Node.js. So I'm going to specify US Central again. All right, so we're creating the application in our project. Applications are nested in projects. All right, and again, it's showing us our deployment URL, and it's showing the service that's being deployed. So we want to say yes to that. All right, and this is our first deployment of this application, so this is going to take a while. So this is where I pause and check back in when we're done. Okay, so we're back here and we've got an error. And sometimes I like to walk you through these errors that I encounter as I'm doing these demonstrations. Because there's a good chance if I'm running into the error, you're going to run into it too. So it's good to know how to solve these problems. So, all right, I'm going to go. We've got this error here. It says billing must be enabled for activation of service, which is strange because we should have that $300 credit. So let's look at Gcloud config and list. All right, and we've got the correct Gmail account and project, so that should be good. Okay, now let's take a look at the console. So here's our Node.js app. Let's take a look at our Sinatra. So I click up here on the drop down and select the Sinatra app. Okay. And let's look at billing. All right, and for some reason, it prompts us to set the billing account. So I'm going to set it to my billing account, set account. Okay, so I've still got my $300 worth of credits remaining. So we should be okay. So you just want to make sure if you run into this error, this one here, it says operation does not satisfy the following requirements, billing enabled. Billing must be activated. Billing must be enabled for activation of service. You want to make sure you've got your billing active over in the console. So the way you can tell is by taking a look at the billing menu. And if you, a sure sign that you might have a problem is if it asks you to add a billing account. And typically you can just select the one that's already in existence for your organization, like I did, my billing account. All right, so now we should be able to run it again. I'm going to run Gcloud app deploy, and hopefully that resolves our issue. All right, and again, this is going to take a while, so I'm going to pause for now and come back, and I'll let you know if that resolved our issue. Okay, so we're all deployed now. Everything looks good. Let's just scroll up and briefly kind of walk through this again. So it's going to be very similar to the Node.js deployment. And so here we see where we left off right here. We're deploying the service, and we're grabbing our image, our container image for Ruby. Right here it says Ruby latest. Okay. Then we're running through our deployment in our intermediate container. All right, so we scroll down and you can see where our gems and our gem file and all the dependencies are being installed right here. All right, and then we're executing our rack up down here. And scroll down. All right, so this indicates it was successfully built. So now we're just pushing it to our final destination, the final destination for the container engine. And again, the threaded push here. And there you go. So we're all good. So now if we do a Gcloud app browse, like it specifies and like we did before, it'll open it up and we should see some cats. Sometimes the links are dead links that we're getting from the cat API, and I don't have a check for that in this app. It's meant to be a really simple app, so we'll just try another and we should get an actual cat image on the next one. So there we go. So here's our cats. So our application works. All right, so let's go back to the command line. And let's do Gcloud app -- help. All right, so this is, if you wanted to know what you could do from the Gcloud tool for apps in particular, and you would do it like this. You would just do a Gcloud app help. right? And we can kind of see our different command groups. So if we did, for instance, a Gcloud app instances and list, we would see both of our instances running. Okay, so now we can see our app instances listed here with some information. So we've got the service name, which is default for both. Version is going to be exactly the same because we deployed around the same time. The ID is what's going to differentiate between the two. And then we have a VM status. So, okay, now we can actually use describe. So we can do Gcloud app instances. It's in the instances command group, describe, and then I'm going to specify an ID. So I'll just take this first one. It's likely our Node.js application. So let's just grab that. I'll paste that in. And then we also need to pass for this command a service. And it's going to be default. And we need a version. So version equals. And I'll copy that and paste that in. Give you a moment to catch up and type that in if you're following along. Of course, you'll want to substitute in your own numbers. All right, so let's run that. Okay, so actually this happens to be our Sinatra application that's running. And it's got information like our start time and the IP and the status again, it's running, okay? Now, another useful thing we can look at, and let me show you. Let's see, we got, if you remember, we can list our configuration with Gcloud config. It's in the config command group, and then list. So right now we're taking a look at our Sinatra application again. And when I do a Gcloud app logs read, it will actually allow me to read the logs on the system. All right, so I'm going to pipe it to less so I can navigate a little easier. All right, and there we go. So you see kind of the startup, and you can see some calls here, some REST calls, where I had loaded up new cat pictures. So that's what that is. So yeah, it's kind of handy. If you're having issues, you can view the logs associated with the service running. So pretty useful. And you can do a tail too. If you noticed earlier, it indicates you can tail the logs while things are running. So now we're tailing. There's no new writes unless someone was actually using the application, but also useful. All right, and you can also view operations on your app engine project. So here we have some operations, and kind of similar to the describe process in the previous one, we can describe each of these operations because it's not all that useful here. We can see a start time and a status, but we don't really know what it was. So we can do a Gcloud app operations describe, and then we can specify an ID. So I can grab this first one. All right, and there we go. So we actually have the deletion of an instance, and that's likely our intermediate instance that was stood up to test to make sure that the app was deployable. So that's what happened there. All right, and lots of useful information, VM zone, the region that it's in, the operation, time data, things like that. If you're auditing after some kind of situation, you're trying to figure out what happened, it's a good idea to take a look at the operations like this, and you can kind of see, you can start framing the picture and getting the time frames for when things may have happened. So useful tool there. All right, I'm just going to go through a few more. Here's Gcloud app services list. So list the services, and default is what we're using. And we can actually describe that with Gcloud app services describe default. All right, and then there's our Sinatra application service. Okay. We can also view regions. So this command, it will actually return all of the regions available for this Google Cloud component. So it will say I can run App Engine in all of these different regions. And again, there are these regions that I talked you through when we were setting up the configuration initially. And this is an easy way to tell, like, okay, which regions can I use for this particular technology? Well, I can just use the Gcloud CLI and type in app regions list, and that gives me all of my options. One final thing I want to show you, it's kind of handy. Instead of going to the browser and typing in the URL for Google Cloud and then clicking on your console, you can actually do a Gcloud app open console, and it'll bring you to the dashboard for this project. And as long as you're already authenticated, it should take you right there. So see, you have cat times Sinatra, so it's taking me to the project, to the dashboard. And you can see here's our diagram of requests. So cool stuff. Okay, so I just wanted to walk you through some basic Gcloud CLI tool functionality for the App Engine. So that's all I want to talk about for deploying Sinatra and then taking you through some of these Gcloud CLI operations. So go ahead and mark this lesson complete and move on to the next. Thank you for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to walk you through deploying a standard runtime application with the Google Cloud App Engine. Okay, so the first thing you need to do is check your Google Cloud config for the CLI tool. So Gcloud config list. All right, and I've got a new project checked out, and you want to do the same. So go ahead and create a project and check it out if you haven't done so already. And I'm logged into my Linux Academy cloud server right now, where I've got my Gcloud CLI configured. All right, so the next thing I want to do is install a new component. So this application in the standard runtime is going to be a Python application. So we need to get the App Engine Python components. And we can do that by running Gcloud components install App Engine Python. Just like that. All right. And we'll say yes. And this will take a couple moments. And for this project, we're going to utilize some of the example code that Google Cloud provides. And they've got a ton of stuff you can do that's just freely available. We're going to clone that repo now. And you can kind of look through. This particular repo has all of their Python examples. So it's Git Clone, https://github.com/Google Cloud Platform/Python-docs-samples. Oh, and we need to install Git here. So yum install Git, sudo yum install Git. There you go. And for your local dev environment here, where we just have Gcloud installed, the 1.8.3 version that comes with CentOS 7 or is available with the base set of packages for CentOS 7 is going to be just fine. So that'll work for us. And then we'll do a Git clone. And I'm just here in my home user directory. So now I'm going to cd to Python, so the root of my repository, App Engine, and then standard, so standard environment, and then hello world. So we're going to look at their hello world application. Okay, so I'm just going to run this locally to test, and you do that by this command here, so dev app server.py, and then pass it app.yaml. All right, so it's running now. I'm going to hop over to another tab I have open, and I'm going to curl that. So curl localhost 8080. Let's see if that works. All right, good. So that's working. Now let's modify it a little bit. First, let's kill the running server. Control C. And let's modify main.py. And we'll say hello Linux Academy student. All right, let's run that locally now. We'll curl that over here. And we should get our new text. Okay. So that looks good. Let's kill that. And before we move on, let's take a look at app.yaml. Let's take a look at that app engine configuration file. All right. So for runtime, we have Python 2.7 specified. It's because we're going to be running a Python 2.7 runtime. API version is 1. It happens to be the only API version for Python 2.7. And then there's thread safe. And that indicates the app can handle multiple concurrent requests. And then we have our handlers. So for those requests, we're saying this path, this URL, which is basically everything. We'll use the main.app to handle any requests. All right, so pretty simple configuration here. Now let's deploy it. And that's simply Gcloud app deploy. And we need to choose a region. And I'm going to choose US Central. All right, and this will take a while. Okay, so I am being prompted to go ahead and create this App Engine instance in this project, in this region. Okay, I'm about to deploy the service to this URL, and I'm going to say yes. Continue. All right, and this will take a few moments as well. Okay, so our app is now deployed, and we can get there, if you remember, from Gcloud app browse, and that's just going to open up Firefox for us in a tab, and oh, it's not going to work for you from the cloud server instance, so we need to click on it manually here. So let me just copy this URL, and I'm going to paste it in. I'm going to paste it into Firefox, and we should see our app running. There it is. Hello, Linux Academy student. So we've got a deployed standard app engine app running with the Python runtime. Okay, so I'm back over on my cloud server instance, and now that we've got it running, and we don't really need it to continue running, let's go ahead and delete it. So let's do a Gcloud app instances list, and that'll give us our list of instances. All right. And then we need to run Gcloud app instances delete, and we'll specify this ID right here. So I'm just going to paste that in. Oh, and they also need the version. Okay, so -- version. And it also needs service. And this time it's going to be default. And it'll ask us to confirm, and there we go. So we've deleted. Now we can do a Gcloud app instances list, and it'll be empty. Listed 0 items. Okay, that's all I really wanted to cover in this lesson. So go ahead and mark it complete and move on to the next. Thank you so much for taking the time. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to talk to you just a little bit about the Google Cloud Compute Engine. Okay, so what is it? What is the Google Cloud Compute Engine? Well, it's a platform for launching virtual machine instances in Google Cloud. So that's basically what it is. The compute engine facilitates the creation and management of virtual machines within your Google Cloud infrastructure. All right, so what are some of the features we have? Well, it includes small persistent disks. It's configurable via the Gcloud CLI, the Cloud Console, or client APIs. There's some client APIs out there for Python and Ruby and some of the more common languages. I think there's now 7 client APIs, so those are useful for programmatic management of Google Cloud. Compute instances are assigned to a default virtual private cloud automatically. All right, so all VM instances will automatically be added to some virtual private cloud network. All right. Also, a note on regions and zones. As with all other resources in Google Cloud, VM instances exist in regions and zones. So it's something to keep in mind. I'll always be thinking about, you know, what's a little bit different about the app engine and the compute engine is with the app engine, you don't really concern yourself with where instances are located because that's all abstracted away from you. But as you design an infrastructure with the compute engine, you want to think about, well, I don't want to put all of my compute in the same zone. And maybe even I want to distribute it across multiple regions, especially if it's something that an application that's used globally or has global appeal. You want to distribute not only for resiliency, but for performance and reducing latency. All right. So machine types. So there's this concept of machine types in Compute Engine. And basically what defines or characterizes a machine type is the memory size, the CPU count, and the maximum persistent disk capability. All right, so I think it's best to illustrate this through an example. So I'm going to show you the F1 micro example. This is the smallest type of machine type for the compute engine. And it comes with one virtual CPU. So a virtual CPU isn't actually associated with a singular physical CPU. It can actually be shared amongst nodes. It's kind of a similar concept to what you would see in a hypervisor like VMware, where some compute or processing power can be distributed across multiple instances from a single core. It's kind of like that. It's like a shared CPU that's used when it's needed. Then it comes with 0.6 gigs of RAM, so not a lot, but that's plenty to run a lot of simple web applications, for instance. It can have a maximum of 16 persistent disks. Like I said, it comes with a singular one. And the maximum persistent disk size is about 3 terabytes there. Okay, and we're going to use the F1 micro for our demonstrations because our applications are very lightweight and it's going to serve our purposes just fine. All right, so images. So images are the operating system boot images that are used to deploy compute engine instances. And there's a bunch of different ones. So you've got a lot of options. Some are supported by the compute engine team. Some are supported by third party. You can even add your own or customize and store them in your Google Cloud organization and use them as it makes sense. So yes, these images, they can be public or private. Like I said, you can have your own in-house that are stored within your own projects within Google Cloud. And again, yeah, subset, supported by a compute engine team. And you can actually use the cloud launcher for pre-configured images. So these are solutions that are already configured and up and ready. You might see like a LAMP stack or a Rails machine or Node.js, just pre-configured systems or solutions that are available in the cloud launcher. There's a lot of different ones. Okay. And there's also this concept of image families. So for example, you might see, for instance, the image that we're going to be utilizing for our compute nodes is CentOS 7 version 2017 0426. All right, so that indicates it was the version as of April 26, 2017. Well, that image is in the CentOS 7 family. So usually the family corresponds to the actual type of image it is. So it's a CentOS 7 image, so it's in the CentOS 7 family. If it was a Debian image, it would be in the Debian family. Okay, well that's basically all I wanted to talk about here for the compute engine. We'll get further into it as we start using it and apply it to our web application infrastructure. So let's go ahead and mark this lesson complete and move on to the next. Thank you very much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to be walking you through the adding of our source code repositories using cloud source repos provided by Google Cloud, and I'll also be adding our project for our compute architecture, for our compute use case. Okay, so the first thing we need to do is add that project, because we can't add the repositories without a project to add them to. So as you can see, we've got our Sinatra project as the current active one. And we could click here and add a project via this menu like we've done before. But I just want to this time use the Gcloud CLI tool to do that. So let's make sure our config is correct. So we'll do Gcloud config list. Okay. And that looks okay. So our account's correct. So let's do a Gcloud projects and then create. And now I'm going to specify the ID cat time compute, because we're using our compute engine for our use case this time. And then I'm going to specify my Linux Academy username, Brandon423. In my case, substitute your own if you're following along. And then I'm going to specify for a name, cat time compute Brandon423. Okay, that's your syntax. All right, so we're creating that. That'll take a few moments. All right. Now let's look at our config again. Config list. All right, so it's still got the project set to cat time Sinatra, so we want to change that. So let's change it to, so do a Gcloud config set project, and we want to change it to the project we just set up. So cat time compute Brandon423. Okay. And we can look at our projects. We can do a Gcloud project projects list, and we can see now we have our 3 projects. Okay, we did the application in Node.js in the App Engine, we did it in Sinatra in the App Engine, and now we're working with compute. Okay, so now let's go back to the console. And I want to switch projects, and sometimes there's a delay in the new project showing up. Oh, there it is. Okay, good. So we can select that. And now I want to add a couple of cloud source repositories. And cloud source repositories are private Git repos that live with your project. They're kind of nice. They can integrate with other sources like Bitbucket and GitHub. There's also Stackdriver integration. Stackdriver is kind of the monitoring performance suite that goes along with Google Cloud. There's some integration that can help you with debugging of code. It's free for up to 1 GB for this beta release. It comes with a nice source code browser, which I'll show you in a little bit, and integrates well with Google Cloud credentials and permissions. It's all automatic, so that's really nice. It's nice to be able to keep that all on the same platform. But anyway, let me scroll down here on the left, and I'm looking for source repositories, and then I'm going to click on repositories. And I'm going to click up here, create repository. And we've got a couple to make. So we're gonna do the same thing we did with the app engine. We're gonna deploy a Node.js application with compute, and we're gonna deploy a Sinatra application with compute. So we actually need the same repository. So content, GCP, essentials, Node.js for the first one. And it's just going to be an empty repository for now. And let's go ahead and add another one. I'm going to do the same for the Sinatra repository. So content, GCP, essentials, Sinatra. And we'll create that one as well. Sorry if that's a little hard to read. That's a really light gray text in that menu. All right, and now what we're going to do is push code from a local Git repository to our cloud repository. That's how we're going to set it up. So you could click here and it'll give you some instruction. We're going to do the same thing. So I'm going to go back to my terminal, and I've got them checked out here. So let's do the Node.js one first. And if you don't have them checked out from GitHub, you want to go ahead and do that now. Okay, and what I want to do first is the Gcloud init, and let's create a new configuration. All right, and this time we're going to call it cat time compute. This doesn't have to be unique to the world. And I'm going to use my demo account. And for project, I'm going to use 1. And the compute component is not enabled, so we're going to go ahead and get that enabled. Okay, good. So now the Google Cloud SDK is initialized for our project. And if we look at our config now, our project's correct, our account's correct, everything's good. Okay, and we've got our configuration that's set up for this this particular project, so that's good. Okay, and now I'm going to run this little helper script to help set up our credentials for Google Cloud. So let's run that from inside of the repository. Okay, so that's run. And now I'm going to add a new remote, and we're going to call it Google. Okay, so I'm going to add a remote, and we're going to call it Google, and I need to grab the URL from the console. So you can view it here in the instructions, or if we close that and went to repositories, you would see the clonable URL here in this middle column. So let me make that bigger. Okay, so for Node.js, I'm going to grab this clonable link, and that's going to be our remote. Okay, so I'll add that, and then I'm going to push. So git push -- all Google. So I'm pushing to the Google remote. All right, so that's pushed. Now if I go back to the console and I click on it, there's our repo. So we've got all of our our files we're familiar with. We got our app.js, app YAML, package.json in the public folder. So everything we expect. And here we can view commit history. And it's a pretty simple code browser. You can view branches here and tags. And then you can switch between repos here. Create new, manage. So there you go. And if you wanted to remove, you could do that over here. Okay. All right, so now let's do the same thing for the Sinatra repo. So I'm going to cd into that repository, GCP essentials Sinatra this time. Okay. And we should be good with our config. Okay, so I'm going to run that helper script again. All right. And now I'm going to add a remote again. So git remote add Google. And I'm going to grab the link from here again. So Sinatra. All right. And I'm going to do a git push -- all Google. All right, perfect. So now if I go back to the console, I click on Sinatra, there it is. There's all my files. Okay. So now we've got both of our repositories in our new Google Cloud project that we're going to be setting up an architecture with compute engine instances. And it's all set up. Okay, well that's all I want to cover here. So go ahead and mark this lesson complete and move on to the next. Thank you for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to be walking you through setting up our CatTime Node.js application on the Google Cloud Compute Engine. Okay, so just like we use the app engine to set up our web app before, we're now going to do the same thing with compute. And it's a little more involved. That's the advantage you get with compute over the app engine. The app engine comes with a kind of a predefined architecture, and compute allows you to kind of craft your own. So that's what we're going to do here. So for this first example, and I'm going to go through a couple of different ways to establish your compute node instances. So this time I'm going to use the console. So I'm going to click on the menu here, and I'm already logged in. So you want to make sure you get logged in. And I'm going to scroll down to Compute Engine and click VM Instances. Okay, and so since we just set up this project, we need to associate it with our billing account. So you may have to do this as well. So I'm going to choose my billing account. It's the only billing account associated with my Google account. So I'm going to select that and set account. So you may have to do the same. Okay, so now I can select create. Well, no, it's going to make me wait. All right, so this might take a couple minutes. So I'll pause here and jump back in when this is done. Okay, so our billing account is attached to this project now, so we can create VM instances. So that's what I'm going to do. I'm going to do a create. All right, and we're going to call this instance, we're going to call it CatTime and Node.js. All right. And for zone, I'm going to choose one close in proximity. So I'm going to choose US Central 1C. Now it's automatically giving us actually quite a bit of RAM. So notice this would cost us about $25 a month to run, and it even shows you an effective hourly rate. So 0.034 cents or $0.034 per hour, 3.4 cents. And you can even view a detailed breakdown here. All right. And you get a little discount for sustained use if you click here on the help. Instances are discounted up to 30% monthly based on the duration of use. So that's cool, but we don't actually need 3.7 gigs of RAM to run this little web app. So let's customize it. All right, and we can click Basic View and Customize to get our different views. I think we're good with one core, even a shared, and a 0.6 gigabyte. All right, so this is actually it's considered an F1 micro instance. And if we click choosing a machine type, you'll get a breakdown, right? Predefined machine types. And here's a breakdown of all of those, and the cores available, and the RAM, and the maximum number of persistent disks. Lots of different options there. But you know, this is a very tiny web app, single page, not a whole lot of resource intensive functionality. So we're good. We're good with one shared virtual CPU and 0.6 gigabytes of RAM. Okay, so now we'll scroll down. We need to change our boot disk. We want to use CentOS. So I'm going to change this. And over on CentOS 7, you can select that. And I'll choose select. All right. We're going to, for a service account, we're going to just use the default. Now that this service account, it will be the active account on the instance. So any type of operations you want to do on your Google Cloud will use this service account. All right, so we need to set some access scopes. So I'm going to set access for each API manually. And there's a few I want to change. So cloud source repo. So we need to be able to operate on our repositories. So I'm going to give it full access to our repos. Compute engine as well. We're going to give it read write. Service control is enabled. So that's good. Service management will go with read only. That's good. Stackdriver, logging, monitoring, write only, Stackdriver trace, write only, and storage, read only. Okay, so perfect, that's good. Now we want to allow HTTP traffic and HTTPS traffic. And that's all we need. So otherwise, you can also view some more options here for management disks, networking, SSH keys. It's okay though, and you can specify a startup script as well. But we're not going to get into that in this lesson. So let's just do a create. Okay, so that create will take a few minutes. So I'm going to pause here and come back when it's done. Okay, so now our compute instance is ready to go. So I'm going to click back over on the browser. And I'm going to go to my Linux Academy page. I'm going to get logged in. And I need to spin up my instance that has my Google Cloud SDK on it. It's this one, start. All right, so I'll pause, come back when it's ready, and we'll move forward. Okay, so my cloud server's up, so I'm just going to copy the public IP and get logged in there. So, right, and SSH user at public IP. I'll get logged in. All right. So I've got my Gcloud set up. Let's take a look at our config. It's always a good idea to do that. All right, so we haven't set up anything yet. Okay. So what we need to do now is do a Gcloud init. All right, and I'm going to go ahead and get logged in. Now, since there's no GUI associated. There, I've got to start that up again. Okay. Since our cloud servers don't have GUI, it's going to give you this link. So you'll have to copy it and paste it into your local browser. And it'll ask you to log in. And I'm going to choose my demo account. And I'm going to allow. And it'll give you this code. So I'm going to copy that and go back over here and paste it in. Okay. And I'm going to choose my project. It's going to be number one. It's going to be cat time compute, and then my LA username Brandon423. All right, and we do want to configure the compute engine, so let's do that. And we'll make our default zone 14, US Central 1C. Do one that makes sense for you. Okay, so now we should be able to view our instances. So if we do a Gcloud compute instances list, and we got to give it a zone. So let's give it zone equals, and what we gave it US Central 1C, I believe. Let me verify. Yes, US Central 1C. Okay. US Central 1C. Oh, zones. Oh. Little syntax error there. Okay. 1-C. There we go. Okay, so there's our instance. And you notice it gives you the name, the zone, the machine type. So we've got the F1 micro. It's the smallest instance you can get. And then you get your internal and external IP. Okay, so very cool. Now, I want to get logged in. And I can actually use the Gcloud tool to do that. You can use Gcloud to SSH, and it handles all of the credentials. So what I'm going to do is Gcloud compute, and then I need to specify a project. So -- project is cat time compute Brandon423, and then SSH, and we got to give it the zone again. So -- zone equals US Central 1-C. And it's you give it the name of the instance, so cat time Node.js. All right. So this will get us logged in. All right, and that's fine. We can allow it to do that. And I'm not going to give it a password. Defaults are okay. Okay, so I'm logged into my instance now. And if you look at the config, I mentioned the service account earlier. If we do a config list here, it'll have that as the active account on the instance. There you go. So it's got this developer service account, and it automatically has the project added. So you get some pre-configuration when you set up a compute instance. All right. So now I'm going to, as a prerequisite to interfacing with our cloud source repositories, we've got to get a newer version of Git. All right, so let's go through the installation of that. So I'm going to sudo to root. Okay, become the root user, and then I'm going to install some dependencies. And this will take a few moments. All right, and I'll say yes. Okay, so now those are installed. We've got a couple more dependencies to install for Git. And so by default, this CentOS 7 image, it comes with a 1.8 version of Git, and we actually need 2.01 or greater for the functionality with the cloud source repository. And this is something we could automate with a startup script or using some config management tools, but we're just going to run through it quickly manually. All right, so now we need to remove Git. So we're removing the old version. And you'll notice, yeah, 1.8.3.1. So let's go ahead and remove that. All right, now I'm going to move to user source, and we're going to pull down. Actually, we need to install wget, so let's do that really quick. All right, so that's installed. Now I'm going to pull the 2.0.5 tar file, and we'll download that. Okay. And I'm going to unpack it. So tar xbf and specify the file. Okay, and I'm going to move into the unpacked directory. And I've got a couple make commands to run. And this will take a while. So I'll pause here and come back when it's done. Okay, so that one's done. And we've got one more make command to run here. So we're going to run this make prefix user local git install. All right. And I'll check back in when it's done. Oh, there we go, it's done. That one runs a little faster. Okay. So now we need to add user local git bin to our bash rc. This command. And now let's just source it. Okay, and now we should be able to run Git, and we'll have the newer version. There it is, 205. Okay, perfect. All right, next I want to install Node. All right, so I'm already the root user. So let's change directories to our home directory, and we'll do a wget. We're going to grab the current version of Node.js. All right, it's this URL. And you'll see in the study guide, there's kind of a walkthrough for how to go about this, and I'll try to add in all the relevant URLs to the description of the video. But we're going to download Node here. Okay, and let's unpack that. And actually, we need to let's make a destination directory. So make dir node, keep it generic. And then we're going to unpack it. Oh, it's XZ. Okay, there we go. Different compression. All right. So now let's cd into Node, and we should see all of our Node files. Okay. So I'm going to make an etc directory inside here. And then I'm going to create an npm rc file within etc. Okay, and I'm going to move out of the directory. I'm going to move node into opt. And I'm going to chown, changing the permissions, and make sure root is the owner, op node. All right, I've got a couple symlinks to set up. So we're going to make sure these node commands, node and npm, are in our path. So we're symlinking them to user local bin. Oh. And this is npm. Okay. Now we need to edit sudoers to add user local bin to the secure path. So let's bi etc sudoers, and we're looking for secure path, and let's see. And we're going to add one user local bin. Okay, I got one more change here. So let's open up etc bash rc real quick. And jump to the bottom, and let's add user local bin. User local bin. All right, and let's source that. And then we should have node, okay. Node-v, we should have 7.1 or 7.10.0, and npm-v, we now have 420. Okay. All right, so in the app engine, we just ran a npm start to run our application. And that's okay. It's a light way to run a Node application, but we're actually going to use PM2, which is a way to run daemonized Node JS applications. So I'm going to install that now. So we're going to use npm, and that's the Node package manager. We're going to do an npm install PM2 at latest -g. Okay, so got that installed. Now I'm in the home directory. I'm going to now clone our project. All right, so that looks like Gcloud source repos clone. And you specify the name of the repository. So content GCP essentials cat time Node.js. And then we need our project name, --project equals, and it's going to be, for me, cat time compute Brandon423, and substitute your Linux Academy username. Okay, so I'm going to clone that down. Okay, let's take a look at this. So we'll look at our config, Gcloud config list. Cat time compute 423. Okay. Now let's take a look at our menu and scroll down. And here we should see our repositories. Ah, I see. Okay. There's no cat time there. So it's just content GCP essentials Node.js. Okay. That's fine. So let's clone that. Okay, and as we did before, when we ran the application locally, we need to install our dependencies. So I'm going to cd into the repo. Right, I'm going to do an npm install, and it's just going to install what's in the package.json and all the dependencies. And this can take a few moments. Okay, and now I want to export a port, because we're not going to be using 8080 this time. We're going to just be using port 80. All right, and in the app.js, if you notice, it will take in an environment variable or 8080. So it defaults to 8080 and if there's no port environment variable. So I'm specifying that here. Okay. And now we'll do a pm2 start app.js -- name equals cat time. All right, and there you see it. It's running. Online, shows your CPU and memory usage. All right, so, and you can do a couple things. pm2 list. And we can also do pm2 stop and start, but we'll leave it up now. Let's go ahead and check locally to see if we can pull down our page. So we'll just do a curl on localhost. All right, that looks like our web app. Now we should be able to go to our browser, but let's take a look. We'll do a Gcloud compute instances list. All right, and we'll grab this external IP. I'm going to go back to the browser, and we should be able to hit that IP and see our cat time. There it is. All right, so we're running our application in Google Cloud and using the compute engine. All right, so that's basically all I wanted to cover for this lesson. So go ahead and mark it complete and move on to the next. Thanks so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson we're going to be deploying our Sinatra application with the Google Compute Engine. Okay, so I'm logged in again in my cloud server instance, and this time I'm going to create my compute instance with the Gcloud CLI tool. All right, and I've got a command written out here. I'm just going to paste it in, and then I'll kind of walk you through it. Okay. All right, so we've got Gcloud Compute. It's in the Compute command group. Instances, because we're creating an instance, we're acting on the instances command group. We're naming it cat time Sinatra, and image family is CentOS 7, and the type, as I talked about in the previous lesson, the F1 micro, the 0.6 gigs of RAM, and the single shared core for CPU. In zone, I am actually going to have this one in a different zone. I'm going to put it in US Central 1F. Image project. Now, image project is actually the project associated with the CentOS 7 image itself. Let me trigger this first, and then I'll kind of show you where that's derived from. So we've also got our scope set here. So if you remember in the previous lesson, or in the Node.js deployment, I had specified a set of aspect scopes, and these all correspond to the exact same aspect scope. So compute read write, so that's read write on the compute engine. Service control, same. Service management, same name. Logging, we have write. Monitoring, we have write. Storage, we have read only. And then this, the source repository full control, doesn't have a short a shortened version, like all of these do. So anytime that's the case and you want to use an aspect scope, you can actually put in the full URL here for that particular scope. And that's what I've done here. And then we're using the tags HTTP server and HTTPS server. So if you remember back on the console, we wanted to open up HTTP and HTTPS traffic on our instance. So that's what all this does. Actually, by specifying these tags with these exact names, it opens it up. All right? So now let's trigger that thing. And this one takes a few moments. So if I hop back over and close, that's our Node.js deployed application. Let's go back to our menu. And scroll up, compute engine, and then we can look at images. And I just wanted to show you. Let's hide that info panel. So here we have CentOS 7 created by CentOS in the CentOS 7 family. Now if I click on it, it's not terribly intuitive, but you can see up in the URL, it shows CentOS Cloud. Okay, and if we go back to the terminal, you notice I used image project CentOS Cloud. So that's what it corresponds to. All right, so if I go back in, it's this project's CentOS Cloud. That's where that's derived from. All right, so now if we go to VM instances, we'll definitely see our Node.js instance. And yeah, we see our cat times Sinatra instance now. Now I just want to show you a couple of options for logging in. You can actually click here, and if you just click SSH, it's going to open up a window, and you'll be using the Google Cloud terminal. And it's like a popped out window version of what this is as well, the Google Cloud shell. So we can either do that, or we can use the Gcloud command, which is what we're going to do. We're going to go back to our instance, our Linux Academy Cloud Server instance, and we're going to use Gcloud. So if you ever have trouble remembering a command, know that oftentimes there's little helpers that will tell you what the command is within the console. So I click here, I click View Command, and it gives me the exact syntax for the command I need to run to SSH to my node. So I can copy that, and I can go back to my terminal now, paste it in, and there it is. So that's the exact syntax I need to SSH to it. So let's try it. And there we are. We're logged in. We're logged into our new instance. So a lot less clicks involved than using the console. But you have to be aware of all the different options. And some of them are a little tricky, like the image project. So whenever you're trying to track down an image project, just make sure you look at that URL in that particular spot, and that's a good way to find out. Okay, so now we're logged in, and we want to install Rvm Ruby version manager, because we want to run a particular version of Ruby. All right, so I'm going to sudo to root, and I've got some dependencies to install for that, so I'll do these in 3 waves. Right, let's grab this one. All right, and each of these might take a few moments, so I will step away for a moment and check back in with you when these are installed. And I'm ready to install the next group. Okay, ready for some more? Okay, that one went pretty fast, so one more set here. All right, now I'm going to pull down the GPG key from Rvm. And you might remember this process from earlier when we deployed the Ruby version of the web application from your local environment. We installed Rvm as well. So let's do that. It's going to be this command here. All right, and it's imported. And now I'm going to run the install script by curling and piping to bash. All right, we're installing the stable version of Rvm. And it's going to give us the latest version of Ruby, so 2.4.0. Then we'll go back in and install the 2.3.3 release, and we'll set that up for use because that's the current version for the Flex environment within Google Cloud. So I'm going to be using the same thing. So I'm going to kick this off. And this takes several minutes, so I'll go ahead and step out for now and check back in with you when it's done. Okay, so Rvm's done installing. Now I'm just going to source the Rvm binaries. And I do that like this: source user local Rvm scripts Rvm. All right, and now it should be in our path. Yep, all the Rvm commands there. Now I'm just going to do an Rvm install 2.3.3. All right, and there it goes. So this will take a few minutes as well. So I'm going to stop here and check back in when it's done. Okay, so we've installed Ruby 2.3.3. Now we need to actually use it. So Rvm use 2.3.3. Okay, so from a Ruby perspective, we're all set. So now I'm going to get Git installed. And this is the same process we went through on the Node.js version. We're just going to do it again. So let's see. We're already the root user. Let's install some dependencies. So here's our first set. This will take a couple moments. Okay, so those are done. Now we got one more set here. Let's get those installed. And I went a little fast there. Here's that set. And here's the previous. Okay. So now we need to remove the old version of Git. So yum remove Git. Yes. And let's move to user source. And we're going to pull down that same tar file we pulled down previously. So, all right, we've got that. Now let's unpack it. And Git. So we move into the directory. And we've got those make commands to run. So these take a little bit of time as well, especially this first one. So I'll check out here and catch back up with you in a couple minutes. Okay, we're about ready to wrap up this Git install now. That first make command's done, so let's go with the second one. This one goes pretty fast. And then let's add a bit to our bash RC, and let's source it. And then after that, we should be in business with our new Git. So let's do a git -- version. And there it is, 205. Okay, good. So now we should be compatible with our cloud source repositories that are hosted in the Google Cloud platform. So let's clone it. So let's go to cd opt. That's where we're going to clone it to. And we'll do a Gcloud source repos clone content -gcp -essentials -Sinatra this time. And it's going to be project cat time compute Brandon 423. Okay. All right, so we've got our repo So now I want to set up our web server, and we're going to use Apache and Passenger. Before we hosted our Ruby Sinatra application via WebRick, and it's a really nice lightweight way to stand up a web server fairly quickly, but I wouldn't say it's necessarily great for production, and definitely not at scale. So we're going to actually utilize Apache and Passenger, Fusion's Passenger, to stand up our website. So first thing we need to do is install Apache. So yum install httpd. That's the name of the package in CentOS. All right, and then we need a couple of gems. So gem install Passenger and also bundler. Because we remember we used bundler to install all of our dependencies that are listed in the gem file. So this will take a couple moments. Okay, so we've got our gems installed, and there's a couple things I want to do before we kick off the Passenger installer. First thing I want to do is set enforce 0. So we're going to disable SE-Linux. It's recommended by the installer. And we're also going to add some swap, because this is a really heavy-duty install. And especially for this type of micro instance, it's just going to require a lot of RAM, a lot of memory. But it doesn't require that much RAM necessarily to run just on this initial install. All right, so we're going to grab some swap space. So all right, and that involves a make swap. Like so, swap, and then a swap on. So we're going to enable the swap. All right. Now we should have the Passenger install in our path. So yep, Passenger install Apache 2 module. So let's do that. And there's a few questions throughout the install, and we'll go through them. Okay. So it's just saying the Apache 2 module is going to be installed, and it'll give you some kind of helpers on configuring Apache and deploying a Rails application. But there's similar concepts with Sinatra. So we don't want Python, we just want Ruby. All right, and it's checking for the necessary software. Okay, and I need to install httpd devil as well. So let's do that. And the installer for Passenger is really comprehensive. So if you miss any steps, it should tell you exactly what you need. All right, so let's kick that off again. Right, and we don't want Python or Ruby. Okay, so all yeses, that's good. A single installation for Apache is detected, so we're good there. All right, so from this point, I'm just going to let it run. It takes a while again, so sorry for the lengthy installs, but this is the last one we have before we start getting ready to deploy the actual application. So I'm just going to let this run, and I'll catch up with you in a few moments. Okay, so I just want to check back in here. My install is still running. It's been several minutes, and sometimes it looks like it might be frozen or stuck, but it just takes a while. It's a long install, so this might be a good time to go grab some coffee or some other type of beverage and sit back a little bit, maybe read up on the study guide or some documentation. It's kind of a long install, so apologize for that, but we should be able to launch our application here as soon as it's done, which is a couple more steps. So, okay, we're getting really close. We just have a couple of files, a couple config files for Apache. So let's go etc httpd and conf.d. That's where a lot of Apache configuration files go. And let's make a passenger.conf first. So passenger.conf. And I'm going to input something very similar to what the installer showed us earlier. Just like that. And tabs aren't quite right. Okay. So it's just loading up mod passenger and setting passenger root and default Ruby, a couple of parameters for it. So, all right, and it's going to use 233. And now I'm going to add a vhost definition, and we're going to utilize our host name for a server name. So let me set that right now. So vi cat time, or sorry, let's do a cat etc host. Let's see what we have here. Yeah, so we're going to utilize cat time Sinatra as our server name. So let's make we'll call it cattime.conf, and I'm going to paste this in, and I'll give you a moment to copy it in. All right. And all of these are in the study guide, so if you're following along, and I go a little fast on a piece of configuration or something on the command line, you can always take a look at the study guide or follow along with the study guide. Sometimes that helps. Or, you know, of course you can always pause the video and go at your own pace. But this is the configuration. So notice the document root. So server name is cat time Sinatra, looks like I mentioned, it's the host name. Document root is where we cloned our repo, and it's actually no cat time there. If you remember, it's just content GCP essential Sinatra. All right, so that's all set. And now I think we're ready to start Apache. Systemctl start httpd. And then we'll curl localhost. We should get our site. All right, good. And when it takes a little bit, that's a good sign. It's loading up. We see our image link here, and we see our button. So we see this is our cat time application. So now we should be able to go to our browser and find it. So before we do that, remember we can do gcloud config list, or sorry, gcloud compute instances list. We get our 2 instances, and we've got cat time Sinatra running on this external IP, 35.188.2.146. So I'm going to copy that, and I'm going to go to my browser, open up a new browser window, and we should get cat time. And there it is. We got cat time. And that guy's not having a good time with his cats. Let's try another one. Ah. All right, there we go. There's a couple cats just hanging out, looking cool. All right. So yeah, we've got our cat time. Now, I copied and pasted in that link. Another thing we can do, as I think I mentioned before, is we can go and look at the console, and where do I have that up? There it is. Okay. And we can view the external IP here. And we could even click here, and it by default it goes to HTTPS, but we can back out the S, and that'll take us to cat time. All right. So there's our application. We've got it running now in Node.js, and we got it running in Sinatra. So now what we want to do is load balance. We're going to load balance between the two. And there's a lot of reasons to do that. If one instance becomes overloaded, we can go ahead and switch over the live site to the other one. Also, it's a built-in failover. If one of the nodes fails, and which we'll illustrate, then we'll go ahead and switch over to the other. So load balancer is something that's a good idea to have if you have a website that's under any kind of serious load. So we'll get into that next time. But for now, that's all I want to cover. So go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time. Bye for now. Hi, welcome back to Google Cloud Essentials. This is Brandon, and in this lesson, I'm going to talk to you a little bit about working with persistent disks and the compute engine. Okay, so I've created a project, and I'll go ahead and list it here. Gcloud projects list. And it's this persistent disks Brandon 423. All right, so that's the project I want to set. So I'm going to do that now. Gcloud config set project persistent disks Brandon 423. Okay. And now I need to add a compute instance to work with here. So I'm just going to do a Gcloud compute instances create persistent test 1 dash image family, and we're going to use CentOS 7 again. CentOS 7 dash machine type. We're going to use an F1 micro instance again, micro. And zone for me will be US Central 1F. For you, I'd continue to use the zone that you've been using. And dash image dash project equals CentOS Cloud. All right, so we're just going to stand up an instance here. And I've got a syntax error. Sorry about that. There we go. All right, compute's not enabled, so we're going to go ahead and enable it here. So we have a billing issue here. Okay, so I may have exceeded the maximum project, so you might run into this. So I'm going to go to the browser and walk you through how to circumvent this. All right, and I'm going to go to my console. And I'm going to select the project I just created. Go to all, and persistent disks, Brandon 423. And then I'm going to go over to billing and choose a billing account. So I'm going to choose my billing account, set account. Okay. All right, now we should be good. So I'm going to go back over to my terminal and run that again. Yes. All right, and after this, we're going to create one more instance because I'm going to show you how to share a persistent disk between nodes a little bit later. Right, and launching compute instances can take a little bit. Okay, so our first instance is ready. Let's just run that again, but I'm going to slightly change the name of the created instance. All right, so we're going to say persistent test 2 and create that, and this will take a few moments as well. Okay, so we've got our second instance. Now we're ready to start adding some disks. Okay, before we move forward, I want to make sure my config's all right. So I want to make sure my zones are correct. So let's take a look at Gcloud compute instances list and see what zone we're in. Okay, US Central 1F, and I want to make sure that's active in my config. So Gcloud compute instances, Gcloud config list, and we should see US Central 1F. Now, if we didn't see that, the way you would change it would be Gcloud config set like we've done before, but notice it's in the compute section, not in the core section. So you have to specify compute / zone, and then you would change your zone, right? 1 dash A, B, C, D, E, F. Okay. We don't need to do that here because it's all correct, but just wanted to let you know in case you run into issues there. All right, so we'll clear. And now we're ready to add some disks. So let's do that. Okay, so before we add a disk, let's look at the disks we already have. So let's do a Gcloud compute disks list. And we should see a default disk for each instance. All right, and there it is. Okay, so we see our persistent test1. So it automatically takes the name of the compute instance. And we see one for each of our compute instances. And they are small persistent disks, right? They're only 10 gigabytes. And they're of type PD standard, as opposed to PD SSD, which if you're concerned with write speeds and performance, you might want to switch over to a PD SSD, but for this lesson, we'll just stick with PD standards, and then you have a status here, it's ready. Okay. So now let's create a disk. So that's going to look like Gcloud compute disks create, and then it needs a name, so we'll call it test1. And it needs a size, so I'm going to specify a size of 15, and this is in gigabytes. All right, 15, so we can easily distinguish it from the other disks, other than the fact that the operating system's, obviously not installed on it, but it's handy just for being able to tell the difference. Then we also need to specify a type, and we'll do PD-standard. And that's going to be it. So let's make that disk. All right. And yeah, it does indicate that I/O performance can be affected by having such a small disk. That's okay. All right, so we've created a disk. Now we need to attach it to a node instance. So let's do a Gcloud compute instances attach disk. That's the command in the instances group. And then we need to specify our node. So persistent test1, our node or our compute instance. And then we specify our disk. So -- disk. And we'll say test1, right? It's going to take a couple seconds. Shouldn't take too long though. Okay, so it's all done. Now let's log into the node. So Gcloud compute SSH, and then persistent test1. And when we get logged in, we'll run an ls block, and we should see our new disk. We expect to see our one standard persistent disk that the OS is installed on, and we'll see this new disk that we just added. All right, so we're logged in now. I'm going to go ahead and become the root user. I'm going to run an ls block, and there you see it. So we see our OS disk with a partition on it, SDA1, and it's 10 gigabytes, and we also see our new disk, SDB, 15 gigabytes. Okay, so now I just want to format the disk, and I'm going to use an ext4 formatting. So mkfs.ext4 -m0 -big F -big E lazy _ itable _ init equals 0 lazy _ journal init equals 0 and discard. And then I'm going to specify the device name, and in our case it's going to be dev sdb, as is indicated here in the ls block output. Okay, so let's run that. And that'll take a little bit, not too long. It's a pretty small disk, so shouldn't take too long. Okay, so that's done. We've got a formatted disk. Now let's mount it. We'll do a make dir, so we're going to make a directory to mount it to, -p mnt disks, and we'll call it my disk. Okay. All right, and now I'm going to mount -o with the options discard, defaults, and I'm going to specify the path to the disk, so dev sdb, and then the path to the directory we want to mount it to it. So it's mount disks and then my disk. Okay, so we're mounted. And I'm going to run a chmod on that I'm going to give all users read write. So it's like this, mnt disks my disk. All right, and now let's get the UUID so we can add it to etc fs tab. So there we see it. So I'm just going to copy that. All right, and I'm going to open up etc fs tab. This is to ensure the drive gets mounted on boot. So UUID equals, and then the mount path is mount disks my disk, and it's going to be ext4 for the format for the file system. Then discard these options, discard, just like we said before, defaults, no fail, and 0, 0, 2. So tabs between. Okay, looks good. All right, so our etc fs tab is set up. Now let's try to write to the disk. So I'm going to use a dd just to test it out. So I'm going to touch a file there, mnt disks my disk, and I'll just touch test to initially test. See if we can write to it. Okay, great. And now let's add a 1 GB file. So let's do a dd in file if equals dev 0 out file of equals mnt disks my disk, and then test, and byte size equals let's see, 1G, and count equals 1, and OF lag equals direct. Okay, so that ought to work. Memory exhausted by input buffer size. Okay, let's make it smaller. 512 M, and we'll do 2. All right, maybe that's too much as well. We'll do, don't have a lot of memory here, so 256, 2. How about that? Okay. So we'll have half a gigabyte. Might be pushing the limits of this RAM, so hopefully it works. Okay, it worked. All right, so now we can take a look at df. So df-h dev sdb, and we should see good amount of the disk used up there. So used 553 megabytes is about what we would expect. 2 times 256, okay? So 512 plus a little bit for the formatting. So that's about what we would expect. Okay, so we are writing to our persistent disk. It all seems to work okay. Now, let's say we've got a lot of writes to our disk, and we want to resize it. All right, let's say we need 20 gigs instead of 15 now. All right, so let's exit. I'm going to get back to my dev system. Actually, this is my cloud server instance. And I'm going to run gcloud compute disks resize test1. Right, that's the name of our disk. And I'm going to specify a new size. Now, when I specify size, it's in gigabytes, and it has to be greater than the size of the existing disk. Okay, so it's 15. So if I put in 14, it would be invalid, and I'll show you that here. And I'll say yes, and it'll say, sorry, it has to be larger than 15. Okay, so we actually need 20, so let's set it to 20. And yes. Right, and this will take a couple moments, not too long though. All right, so it's ready. Our disk is bigger. So now let's SSH to our system again, and we need to resize our file system. So let me sudo to root, and let's do an ls block again. And there you see it. We now have a 20 gigabyte drive, but it's formatted for 15. So we need to resize. So let's do a resize to fs dev sdb. All right, we're specifying the path to the disk. Right, and there we go. All right, so our disk is updated with the new size on the file system. Okay. Now, let's exit this system. I want to illustrate sharing a persistent disk between nodes. Now, one major limitation to doing this is the disk has to be in read-only mode for all of the instances it's shared between. All right, so this would have to be, to make sense for your use case, it would have to be very static data that never changes. But I'll walk you through it and show you how to do it. All right. So let's go ahead and add another disk. So gcloud compute disks create, and we're going to call this one test2, test-2, and we're going to give it a size of 25. We'll give it 25 gigabytes, and we'll create that. Okay, same error about poor I/O. Okay, so now we can attach it to our first node. So we can do gcloud compute instances attach disk persistent test-1 disk test2. All right. And this is important. We need to specify mode RO for read only. If we didn't specify that, we wouldn't be able to attach it to the next node. All right. So I'm going to attach that here. Okay. Now let's do the same thing, but for our other compute instance. Okay. And now let's SSH, so gcloud compute SSH, and I'm going to specify persistent test1 to start. And we'll do an ls block, and we should see that additional disk. There it is, SDC, it's 25 gigs. Now if I exit and log into the second instance, we'll do an ls block here as well, and we should see the operating system disk, which is 10 gigabytes, and we'll see this one as well. All right, and there you go. And notice it says RO1, so that means it's read only. We can't do anything with it. Okay, well that's all I wanted to cover with working with persistent disks. So go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'm going to talk to you a little bit about networking. Okay, so first up, I want to talk about virtual private cloud networks. And I'm going to keep it pretty basic here. This is an essentials course, and I don't want to overload you with a bunch of network stuff that we won't really get into. So I'm going to stick with the VPC and a little bit of load balancing for this lesson. Now, I want to cover VPC because we inherently are attached to a VPC network when we set up any instances for the app engine or the compute engine. And before I go further, the definition here is a VPC is a global private virtual network partition that adds managed networking functionality to your Google Cloud resources. Okay, when it says global, it means it's actually global. Like you get a segment of a network that spans across all of the regions within the Google Cloud platform. At least all of the regions that you have resources available in will be represented on the network. VPC properties. It provides a global private communication space. So like I said, no matter where your resources are in Google Cloud's infrastructure, they'll be able to communicate with each other in a private manner over this VPC network. It's shareable amongst projects in an organization, so you can actually span a VPC across projects in your organization. It doesn't all have to be in the same project. All of your resources that you need communication between over this private network don't necessarily have to be on the same project. It allows Google Cloud resources to communicate over a private network. And it can be secured with native IAM, identity access management, integration, and support. Networks and subnets. So all projects have at least one VPC. And as I mentioned before, whenever you stand up a compute instance, you're going to be attached to at least a default VPC unless you specify another one. And if there is no VPC in existence, it will be created for you. It will be a default VPC. All right, VPC networks are global, like I mentioned before. The auto mode provides one subnet in each region. Specific IP ranges, more subnets may require a custom mode VPC. So with custom, you can specify more than one subnet in a region, or you can choose alternative IP ranges. So those are the two major advantages of using custom. All right, so the different IP addresses in Google Cloud are there's different versions of external and internal. And when I say internal, I mean specific to the VPC. All right, and IP addresses in general, they're assigned to many resources in Google Cloud. Compute instances, load balancers, app instances, containers, they all have an IP address associated with them. And like I mentioned, there are two major types. We've got external and internal. External's public facing, and internal lives inside of our private network. It lives inside of our VPC network. All right, so external IP addresses. We've got a couple different types, ephemeral and static. External indicates they're public-facing IPs, and like I mentioned, they're ephemeral or static. Static remains consistent, useful for point-of-access resources like a web application or a public-facing load balancer. So if you want to set up a domain for your web application, you may want a static address to assign it to. Ephemeral is the default mode, so you won't receive a static IP unless you set it up and configure it, and there's a small fee associated with it. The deal about ephemeral is if you change or restart or stop your resource, you'll get a new IP address, a new external IP address. So you have to weigh those. For the most part, internal services to your application, you don't mind too much that the IP address changes. There are elegant ways to solve the problem of changing IPs when you have control internally in your network. But anything that's public facing, you may want to use a static external IP address. All right, a couple of features here. Load balancing. All right, so we're going to cover load balancing. We're going to actually configure it a little bit later. Google Cloud can load balance between instance groups. Now, your nodes or your instances have to be part of an instance group in order to be load balanced. So even if you only had 2 nodes you wanted to balance between, you may add, the 2 nodes, one each, to 2 separate instance groups. And it helps with scale. It helps overcome failed or unhealthy nodes. So on the scale thing, if your instance is reaching some peak utilization, the load balancer will go ahead and move requests over to another instance that's available, or another instance group. And also, it kind of works as a failover, a form of redundancy. If you have a failed or unhealthy node, it will also transfer over to a node that can serve the request. And again, it helps with heavy traffic, helps with scale, and it also helps with limiting latency. So you can route to the closest VM, all other things equal, and it will limit the latency in that manner. Now, auto-scaling removes or adds instances to an instance group based on load. And you can optimize cost while improving tolerance to load. So if you've got an application, you're just starting out, and you don't know how much traffic to anticipate, but you also don't want to use a bunch of resources anticipating some huge popularity that brings in a lot of traffic, you actually get the best of both worlds with auto-scaling, because you can allocate just a couple of resources and configure auto-scaling. And if you don't get a lot of traffic initially, you're just going to use what you need. And that's kind of a central concept behind Google Cloud. You only pay for what you use. You never pay for more. The opposite paradigm would be a traditional data center, where you have hardware everywhere, and you're paying for it, you're anticipating load, and there's no way to dynamically allocate resources. It's one of the big advantages of cloud computing. All right, so in that way you kind of optimize cost. All right, well, that's all I wanted to cover for networking in this little overview lesson. We'll get a little bit more into detail in the next couple of lessons on different things we can do, configuring VPCs and load balancing. But for now, I just want to get the topics fresh in your head and get you thinking about it. So that's it for now. Go ahead and mark the lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, we're going to set up a load balancer for our web application. Okay, so I'm going to click over here on my console, and the first thing I want to do is set up a static IP for our web application to live on. Okay, so we're going to set up an HTTP regionally distributed load balancer, and we need a single IP to point at, and from that point we'll set up rules for the load balancer for it to distribute calls between our 2 instances. All right, so let's go down, and I'm going to click on our home page here, and let's get that static IP installed, configured. So let's go to networking. I'm going to hover this, and then I'm going to select external IP addresses. All right, and we have our 2 ephemeral IPs, so that means they're not static. They can change every time a node goes up or down. Okay, so if we restarted one of these nodes, the IP would change. Well, we want to make sure the load balancing IP stays the same, so we're going to reserve a static address. All right, and we're going to call this cat time static IP. All right, and IP version, we're going to use IPv4. And we're actually going to set this to global. And then I'm going to click reserve. All right, so that'll take a couple moments to set that up. While we're waiting on that, we can go back to our home page. And I'm going to do some work setting up instance groups. Okay, so the way the load balancer works is it cycles between instance groups that we set up in a load balancing backend. All right, so what we need to do next is go to Compute Engine and set up a couple of instance groups. So I'm going to hover Compute Engine, selected instance groups, and we're going to create one. And now our instance groups, it's going to be a little strange because there's only going to be one node in each instance group, but that's because it's all we've got, and this application isn't actually going to be under much load. So to demonstrate the concept, I think it'll work just fine. You could add n number of instances to each instance group. So you could say have, 8 Node.js instances and 8 Sinatra instances, and run them both in separate groups, which could give you some interesting input. You've got two architectures, both providing the same functionality, providing the same web application, but you're able to see which one costs more to run, which one you can view some performance data on both types, and you can say, okay, well, we need to get off Sinatra because Node.js is much faster, or vice versa. But anyway, just to distribute the load balancer, we're going to set it up this way. So this first one we're going to call cat time. Ah, man. It's a little bit hard to read. Let me make this a little bigger for you. So cat time and Node.js-ig. Okay. And I'm going to scroll down and I'm going to select single zone. And for zone, I'm going to select US Central 1C for myself. Now, you want to choose the zone that your cattime Node.js instance is in. So if I go back over here, and I actually just ran it recently, Gcloud Compute Instances List, we're setting up Node.js. So notice my zone is US Central 1C. Okay, so that's why I'm using it here. And I'm going to call this an unmanaged instance group. All right, and I'm going to use the default network. We haven't configured a VPC, but I'll go over that a little bit with you really briefly. The default's going to work just fine for our application, so we haven't configured one yet. So it'll work fine for us. And the subnet, just leave it the same. Use the default. It's the only network, the only private network we have. And then I'm going to add an instance, and it's the only instance in that zone. This zone, US Central 1C. All right, so that's our instance group. And now I'm going to create another one while that one's ramping up. So this time we're going to call it cat time Sinatra IG. Okay, IG for instance group. It's going to be single zone as well, but this time we're going to choose F, because if we look over here, we see that, oh, Sinatra is in a different zone. It's in US Central 1F. So that's where our regional distribution is going to come from. So if one section of US Central 1 goes down, we've got a failover. It's kind of a natural failover. So not only are we going to be load balancing on utilization, so if the CPU and RAM get used up to a certain utilization rate, we'll switch. Also, it kind of gives you a natural failover. If one of them happens to fail and become unreachable, we can fail over to the other. So you've got some redundancy built in there in your zones. All right, so it's also unmanaged, same network. We're going to add cat time Sinatra. It's the only one available in that zone. So we're going to create that one as well. Okay, so while that's spinning up, let's go and set up our balancer. So now I'm going to scroll down and let's see. Yeah, we need to go back to the main page. All right, so it doesn't like the zoom here, so I'm going to zoom out a little bit again. All right, now I can click here. All right, so now I can hover networking and take your time. Okay, and load balancing is what I'm going to click. And there's 3 different options for load balancing. So let's click Create Load Balancer. We've got HTTP or HTTPS load balancing. And that's the one we're actually going to use. You can also use TCP or UDP. All right, but we're going to use HTTP. And we're going to start configuration. All right, and we're going to call it cat time map. That's going to be the name of our load balancer. And the first thing I want to do is set up the backend. And we're going to use a service, create a backend service. And I'm going to call this cat time map backend. All right, and instance group, I'm going to select my first one, Node.js IG, cat time Node.js IG. Port number is going to be 80. Our balancing mode will be utilization. And our maximum CPU utilization. So this is where the load balancer will balance. So if we reach 80% of our CPU utilization, and down here capacity 100%. So that means if we reach 80% of our capacity, which is 80% of 100%, which is 80%, then we'll switch over. We'll balance to the other instance group. All right, now if this was 50, then the actual CPU utilization on the system when it would load balance or switch would be 40%. All right, but we're going to leave it at 80 and we're going to leave capacity at 100 because it's the only thing that this particular node is doing. It's running a web application. All right, maximum RPS we're not going to set, and that's a request per second. So we're not going to set that. I don't imagine it's going to be under a lot of load, a lot of demand. Okay, so for health check, I'm sorry, we need to add one more backend, and that's for the other instance group. So let's do that. Instance group, Sinatra. All right, and it's going to be very similar, the configuration. We're going to do port 80. It's going to be based on utilization, 80% utilization. We're not setting a maximum request per second, and we're going to leave the capacity at 100%. All right. So that looks good. And health check, we're going to add a health check. And we're going to call our health check. Let's see. How about cat time, are you there? Right? So our health check, it's just going to be a simple TCP request on 80. So we're going to use protocol TCP, port 80. There's no proxy protocol. And we're not going to set a request or response. Just any response will work. All right? And we'll use the default request. So that'll be just fine. So all this looks good. We shouldn't have to change anything. So it's really just your default settings. All right, so I'm going to save and continue. All right, so we've got our cat time map backend. It's all configured. It's got our 2 backends. All right, so now we're ready to move forward. We're ready to set host and path roles. And this one's really simple. We're not going to set any, right? Because we've only got one path. These web applications are single page. So we're just going to grab it at their root URL, and it's going to return the home page. That's the extent of the functionality. So all we need to do is leave this, and that should be good. All right. Now we can set up our front end. And if you remember, we set up a static IP. So let's see. Let's call our front end cat time -map -front end. And this one's going to be HTTP as well, protocol, IPv4. It's not ephemeral. So this is where we change it. This is where we set our static IP, and this is the IP address we reserved. So 35.190.25.204. So if we wanted to configure a domain somewhere, this is the IP address we would want to assign the A name to. Okay, and it's going to be port 80. So we're going to hit it at port 80. And that's done. And now we've got our 3 check marks here. If you don't have 3 check marks, make sure you got everything inputted like I went through. Also, take note, there's a walkthrough in the study guide. So if you miss anything, it's a good idea to follow along in the study guide. So also, you can always pause or rewind and watch it again. But yeah, if you've got these 3 check marks, you should be good. So we'll click create. All right, so now that's spinning up, and we'll wait for that. Okay, so we've got our load balancer set up. Now, let's see, let's take a look at our IP. So we'll look at our external IP addresses by clicking here. And we've got our static address. So we should be able to reach it from this address now. Should be able to reach our application. Okay, now there's a bit of a delay, so that's expected. So I'll wait a little bit, and we should have that functioning here in a bit. Okay, so here we go. We've got our cat time. It loaded, and it took about, I would say, 5 to 10 minutes to become available. So if you're having problems initially and you're seeing that 404 page, just give it some more time. And if you continue to run into problems, go ahead and try to hit the ephemeral external IPs, because those should still work. So try to hit these, see if cat time comes up. If it doesn't, then maybe you have problems there as well. So, but I've hit this 35.190.25.204. That's our static IP. And it'll load the page. Now, just looking at it like this, I don't really know which version of the site I have. So let's view the source. It's, if you remember, it's slightly different. So I right-clicked, view page source. Let me zoom in a little bit so you can read it easier. All right, so it looks like we have the Sinatra version, because this, if you remember, this button tag is set up a little bit different. It calls some JavaScript in the Node.js version. Okay. So now what I want to do is kind of illustrate the failover functionality. So I've got Sinatra here. So if I actually take down Apache, that should cause it to fail over. All right, so if I do a systemctl stop httpd, that's the service name for Apache, stop it here. All right, and here we have our Sinatra. Now, let's try to load the page again and see what happens. All right, so it should be going through our health check. All right, just loaded the page. We got a cat GIF here. Cat's digging in the trash can. Now it's stuck in the trash can. Cute stuff. All right, now let's right-click and view page source now. And there you go. There's that slight difference. We've got update pick, so we're calling some JavaScript code. So now it's failed over after failing to reach Sinatra, and it's failed over to the Node.js site. So let's go ahead and start that back up. And see what happens. So it very well could stick with the same version this time. It's not going to prioritize the, yeah, so it's sticking with the same version. So let's take a look at our other one. So let's go to, I'm going to open up a new tab. Or sorry, I'm going to exit here. I'm going to exit. And here I am back in my Linux Academy cloud server. And you notice, let's see, let's change our zone to C, because that's where our Node.js app is. And let's SSH to there. All right, and if you remember, we have that PM2 that's managing our Node.js applications as daemons. So PM2, and we'll just do a list. All right, that shows what's running. It's just going to be the single application. Let's take a look here. PM2 list. Oh, right, sudo su. So it's running as root. PM2 list. There it is. Okay, there's cat time. So now what we can do with PM2 is stop it. So we can do a PM2 stop cat time, and I'll illustrate that it actually fails back over to Sinatra now that Sinatra is running. So let's try this again. We're hitting that static IP that's configured for the front end for our load balancer. Now let's view the page source, and there we go. So there's our function for Sinatra. Just loading the page. All right. Now let's go ahead and start that back up. So PM2 start cat time. All right. All right, so we're all running. And that's about all I want to cover here. Just wanted to illustrate how to set up a load balancer and kind of show you how it works and how it doubles as a failover in case we lose one of the nodes or lose a service. So that's all I want to talk about. So go ahead and mark this lesson complete and move on to the next lesson. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I just want to walk you through setting up virtual private cloud networks within Google Cloud. And it's not really going to add any functionality or enhance our web app architecture in any way. But I just want to walk you through the different ways to go about it in case you do encounter an architecture that requires more than one network, or you want to, maybe you want to use a custom VPC across multiple regions, things like that. So I'm just going to walk you through some of the different ways to go about it. This will be pretty quick. So I'm going to go back to the home page, and I'll show you first how to accomplish creating a VPC from the console. So I'll scroll down. Actually, where are we? There it is. So networking. And I'm going to select VPC networks. And VPC stands for Virtual Private Cloud. All right, and here's our default. So this is defining our default. So if we want to create a new one, we can select Create VPC Network. And let's just call it cat time AutoNet. So this time we're gonna configure it in the automatic fashion. So notice here we can either do custom or automatic. So this time we're just going to go with automatic. And here's some firewall rules. We'll just go with the basic ones. These are all pretty common. You know, you want 22 open for SSH, for instance. RDP is 3389. Probably not have to worry about RDP, but we definitely want SSH. So let's just take all of these standards. Okay. All right, and I would just click create. All right, and now it's spinning up. Now next, after this is spun up, I just want to show you how to do the same thing with the Gcloud CLI. And after we're done with all these, we'll just remove them. So we're not racking up expenses on our free trial account. By the way, I'm going to check mine real quick. All right, so I've only spent like $13 so far. So the $300 can go pretty far if you're smart about it. And I've actually left up my instances. So that $300 should more than get you through the course and a little extra. All right, so there we go. So we've got our subnets within all the regions for our automatically created network. All right. Now let's go ahead and remove it. So we'll click on it, and all you have to do is click delete. Now, before I do that, you can also add firewall roles, even custom firewall roles, if they become necessary. You would do that here. So I'll go back and let's delete this. Okay. Delete VPC network, right? And delete. Okay, now I'll go back, and here I am. I'm logged into my Node.js instance. So let me get out of there. And what I want to do now is create the same auto-created network with the Gcloud CLI. So let's do a Gcloud compute networks create. So it's in the compute networks command group. We're going to create, and this time we'll call it cat time auto net 2. And we'll give it mode auto. All right, so let's try that out, and this will take a few moments. After we're done with this auto setup, I'll walk you through a very simple custom setup. Now, I don't want to go too deep into the networking. I just want to show you some of the possibilities and how to do the basic administration of some common features. Because it is an essentials course, so I don't want to get too deep. All right, and now it even shows you, now that it's created, some suggestions for setting up firewall rules. Right. Now we may not want SSH. You know, this particular network, we may not run SSH on it. We may use a different interface. And so anyway, so now that we've created that, we can actually do a few different things on the networks command group. And if I went --help, always remember --help to kind of view some of the different options. So there's that, and I can do a Gcloud compute networks list. So I can list my networks, and it should give me 2, default and cat time autonet 2. So the other one's already deleted. Now let's delete one from here. So we can do Gcloud compute networks delete, and we've got everything on default. So let's delete auto net 2. We don't need that. Right, and that'll take a few moments. But it's as simple as that. Pretty easy to stand up a virtual private cloud there. And if you don't have any strong requirements for the subnetting or anything, it's really easy to do. You can use auto to set it up. All right. So after we're done with this, I'm going to use the Gcloud CLI to establish a custom mode network. And that involves, it's a little bit more involved. It involves a couple of commands with some options. So first off, we'll do a Gcloud compute networks create. And let's call this one cat time custom net. So cat time -custom -net. And most important thing, specify mode custom as opposed to auto. Okay. So this will give us our network that we can actually configure. And we're going to do that configuration. We're going to actually configure a subnet within it on this next command. So I want a subnet on 192.168.1. So I accomplish that like this. So I do Gcloud compute networks right? Networks command group. Then we're going subnets, so another command group. So networks, subnets, create, cat time, and we'll call it, we're naming our subnet. So cat time, subnet, US, central. So that's the region it's in. And we're going to say 192. That's the first octet. Okay, then we'll go network, and it's going to be the one we just configured, which is cat time, custom, if I can type, custom net. Then we'll have region, and we're going to say US Central 1. All of our instances are in US Central 1, so it would make sense to utilize that region. And then I'll say range. So we're going to specify our range, and we're going to do 192.168.1.0/24. Okay. So let's run that. And then we'll go ahead and look at what we have configured with list, and we'll run it on both command groups. So this is an illustration of nested command groups. So we have compute, which is a command group. We have networks, that's a command group, and subnets, it's a command group. All right, and this will take a few moments. All right, there it goes. Okay, so there's actually what our list is going to show. So, but if you wanted to find that information independently, you would do Gcloud compute networks subnets list. All right. And it gives us our subnet that we've configured, and it also gives all of the subnets that are within the default network. All right. And now if we look at Gcloud compute networks list, we've got our two, and we've got custom and auto. Right, default was an auto configuration, and the one we just set up is custom. Okay, so now I just want to illustrate how the VPC works. So by default, we have the default VPC. So we've got a shared private network between our nodes. So right now I'm logged into both. I'm logged into our Sinatra instance and our Node.js instance. All right, so if we do an ifconfig, all right, so I've got to install it, so you'll need to do this too. -y nettools if you're following along. And I need a sudo there. Okay, let's run a little slow. Do it over here first. Okay, so I've got it there. Okay. All right, I'll clear. All right, so if I ping, actually let's look at ifconfig. So ifconfig, all right, and we see our private IP, our IP on the default. So ifconfig, and if we did say a Gcloud compute instances list, we'd see that listed as our internal IP, 10.128.0.3 and .0.2. So our Sinatra is 3, Node.js 2. All right. Now if we can actually ping between the nodes because they're on this common VPC. So I can ping either 10.128.0.2, all right, or you can actually resolve the hostname via DNS, ping cat time Node.js, right, and vice versa. So ping cat time Sinatra. Okay. Right, so if we needed to utilize a private network between our nodes, it's there. It's there by default. So that's why we didn't really need to change any configuration or add an extra VPC to this particular architecture. I hope that in a future course we can get a little more into some more complex networking stuff, but for now we'll just go with the default. Okay, so that's all I wanted to cover in this lesson, so go ahead and mark it complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I'll be talking to you a little bit about Google Cloud Storage. Okay, so Google Cloud Storage. There are two types of storage provided by, two major categories anyway, of storage provided by the Google Cloud Platform: object storage and their database offerings. The object store is allocated in buckets, so it's a standard object store paradigm where you're utilizing objects as opposed to a directory structure or block storage. And the database options are provided through three different services, and each has their own kind of positives and negatives. All right, so buckets. Buckets are containers for data objects. So we're talking about the standard Google Cloud storage, Google Cloud object storage. There's no nesting or hierarchy. There's a limit of one operation every 2 seconds for bucket deletion or creation, but there's no limit on object operations. So you can delete, create, and overwrite objects as much or as frequently as you want. And it can be managed with the Cloud Console, Gsutil, client libraries, and also the REST API. So bucket naming. Buckets live in the namespace of Google Cloud Storage, so it kind of limits naming a little bit, but they can be used with CNAME redirect. Naming convention. So the name of a bucket takes this form, and it will be projects, then your project, where that blank spot is, buckets, and then the name of the bucket. Bucket labels. Bucket labels can be used to organize and group bucket resources. So it's just a useful label that makes organizing them and allocating them easier from a coding perspective. Objects are the individual pieces of data that are stored in buckets. And the names are just metadata and can be basically anything. There's no hierarchy. Some people attempt to duplicate a hierarchy with their naming conventions, but there is no actual relation in that way. So there's no file system. There's no directory structure. A single object can be up to 5 terabytes. So the very large objects are allowed. Generation numbers are added as metadata when an object is created or overwritten. And that number is generated automatically. So it's not something you have to generate yourself. So whenever you write or overwrite an object, it will receive a number. And objects are immutable. They cannot change throughout their lifetime, but you can overwrite them. So you can't modify objects. A lot of these are common object store concepts. So if you're familiar with Amazon's S3 or OpenStack Swift, you're familiar with a lot of these concepts. So naming convention. Buckets are named in this manner, and you've got project /space/ buckets, and then the name of the bucket that the object is in, and then there's a objects, and then the actual object name. Right, so database options. There's several database options provided by Google Cloud. Big Table. It's the NoSQL Big Data service. So we're talking about using non-structured data. That's what's going to be best for Big Table. Large amounts of non-structured data. Then we have Data Store. And Data Store is actually built on Big Table, but it's NoSQL as well, but it's structured. So it's a document concept. So if you're familiar with CouchDB, it's kind of a similar document-based NoSQL structure. All right, and then we have standard SQL. So their SQL offering, it's a standard production level SQL platform. Provides a traditional relational database. All right, well, that's all I wanted to talk about for Google Cloud Storage. go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm going to walk you through interfacing with Google Cloud Storage buckets and objects utilizing the Gsutil tool. All right, so first off, I'd like to create a bucket. All right, and I'm just going to call it test bucket and then my Linux Academy username. All right, so you'll use the mb command. So this is the basic form for a gsutil command. So it's gsutil, Google Storage Utility is what it stands for, and then the command mb, make a bucket. All right, and then you put in the Google Storage path, which looks like this. It takes this form, gs://, and then you specify the name of your bucket. So I'm going to call it test bucket Brandon 423. Okay. Right, and we're creating a bucket. Okay, so my bucket's created now. Now I want to upload an object or a file to this bucket. And what I want to use as an example is a Linux Academy logo. And I'm just going to curl it here. Okay. So there's my file. There's where you can get it as well. https://Linux Academy templates default assets image Linux Academy logo DKSVG. Okay. And then I'm going to copy it from my local directory to my bucket. And the address for my bucket is gs:// test bucket Brandon 43. All right, so it looks like the operation completed. One object, 6.4 kilobytes. Okay. Now, let's see if it's in there. So we can do a list. So gsutil, and you may recognize some of these commands. They correspond to, typical bash commands like ls, for instance. So you can do a gs:// test bucket Brandon 423. And there it is. There's our file. That's all we have in the bucket right now. Okay, now if we wanted to download something from the bucket, we can do copy again. So it's gsutil copy, but we're copying it from the bucket. So we're going to copy it from right here. Okay. And then we're going to copy it to our local directory. And I'll just put it in temp. How about that? All right, it's copied, and now it should be in temp if we look. Yep, and there it is, right here. All right, so I'll clear. All right, now if I wanted my object to appear in a folder, I can do it this way. I can do a gsutil copy cp. I'll select my file again, but this time, when I put in my target, test bucket Brandon 423, I'm going to add a folder. So my folder. And now when I do an ls, gs:// test bucket Brandon 423, my folder, I'll see my file in the folder. And if I do it on the bucket itself, I'll see the folder in there, and I'll see my image that I have in the root of the bucket. Okay? All right, now we can actually list details for an object. So if I do a gsutil and I do an ls-l and I specify my file, so test bucket Brandon423, and then the file name, Linux Academy logo dk.svg. There you go, got some details about our object. Creation time, and the number of bytes. So, okay, that's how you get detailed information about your object. Now, if I wanted to make an object public, I could do a gsutil acl, ACL, and do a ch-u all users are. Then I will grab the path right here, paste that in, and there we go, we've updated the acl. Now if I wanted to remove it, I'd run a very similar commands, but I'd do, instead of -u, for update, I'd do d for delete, and you remove that, so just delete all users, and run that command, and we'll have an updated acl again. Alright, now I want to delete an object, so how do I go about that? Well, I just do a gsutil rm, again a familiar command, and then the path. So I can actually delete this object. Alright, so if we look again, and I do, let's see, let's just do a gsutil ls gs, and then test bucket Brandon423, we'll no longer have that image in the root, right? So it's just that folder. Okay. All right, so removing a bucket. Now, that's also a familiar command. You'll do a gsutil, you'll do an rm, but you'll do a -r for recursive. And then we'll do a gs:// and we'll specify our bucket, Brandon423. All right. And it's no longer there, so if I did an ls this time, won't find anything, right? Okay, well that's all I wanted to cover with the gsutil and all the operations you can do on buckets and objects. So go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time. Bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson, I'm going to be talking you through a little bit of the functionality of BigQuery and utilizing the BQ CLI tool. Okay, so BigQuery is the big data query platform for Google Cloud, and I just want to show you a little bit of the functionality. We're not going to get too deep into it. It's an essentials course. So we don't want to go too deep on the big data stuff, but I just wanted to give you kind of a glimpse of what's possible. Okay, so the first thing I want to do is I want to do a couple of queries on some publicly available data, okay? So I want to show you, I'm going to click over here to Firefox, and Google, at this URL, BigQuery sample tables, has a bunch of data for you to run sample queries against, right? It makes it really easy. They've got some weather data, they have GitHub data, some registered birth data, Shakespeare data, trigrams data, and some Wikipedia data. So lots of different interesting data sources that you can query, and it all kind of comes for free. So really nice. Okay. So for a couple of examples, I want to do some queries on that weather data from NOAA. All right, and first thing I want to show you is how to view the schema of a table. All right, and this is what I would run. I would run bq show public data samples. So public data samples corresponds to these available sources. Okay, and I want Gcloud, so I'm specifying .gcloud. All right, that's giving me that table. Okay, and I'll click enter, and we'll have our data. Okay, so here's what we've got. Here's our schema, and it's just a big flat table, right? So we've just got all these keys and values, and so we've got a station number, some date, data, some temperature, dew point, sea level, lots of interesting stuff, snow, some Boolean values for whether or not there was fog, rain, snow, hail, thunder, or tornadoes. So, okay, some interesting data. Now, the way you interface with it is with standard SQL queries. So, I've got one written out here I want to share with you. Okay, so here's a BQ query, and we're going to select station number, year, month, day, and mean temperature as temperature from this table here. Same thing, public data samples.gcloud, where the mean temperature is greater than 109, and we're going to order it by mean temperature descending, so the highest first. Okay, so let's run that. Okay, and I'll scroll up, and there's several at 110, and I think that's the maximum for this data set for some reason, because I'm surprised there aren't any higher. But yeah, 110, and then it slowly kind of decreases as we go, and we've got all this data. All right, that's pretty cool. Now I want to add a table to our project, and we're gonna use some baby name data from the SSA, the Social Security Administration. All right, they've got this data about the rates of usage for different names over time. Okay. Now, a couple things I want to do before we do that. I want to make sure we have the correct project set up. And you do that by Gcloud config list. And I've created this project, BigQuery Brandon 423. You want to create your own. Okay, if you haven't done so already. Now, let's download that data with a wget, and it's this URL, http://www.ssa.gov oact babynames names.zip. Okay. All right, we're going to download that. And then you want to make sure you have unzip installed in your local environment. So I'm going to install that. I don't believe I have it installed at this point. Nope. So I'll do yum install unzip. And I need to be sudo. Right, yes. Okay, and I'm going to make a directory baby names. Okay, I'm going to unzip names into baby names. Oh, and that's a -d. Okay. Okay, so I've got all of my data here in baby names. And what I want to do now is do a bqls, and right, so I have no tables or databases set up in BigQuery. So let's add one. So I'll do a bq mk, or I'm sorry, yeah, let's do an ls on public data so you can get an idea of what it looks like. So public data is where those samples were that I showed you earlier, and we should see one one database called samples. All right, so here we go. And it's full of those tables that have all the data about the weather and Shakespeare and all of those examples. Okay, so now let's do a make. So bq mk baby names. So we're creating a baby names. Billing has not been set up. Okay, so let's go enable billing. Okay, go to console. All right, I'm gonna select my project. And a BigQuery, okay. And then I'm gonna go to billing. And I'm gonna select my billing account, set account. Okay, so now we've got an account associated. So I'm making my BigQuery table. Huh. Might be a bit of a delay in working there. Let's try that again. All right, there we go. So it's created. Okay, and now we need to load up some data. And let's grab the 2010 data. Alright, so we do that like this. bq load baby names.names 2010. So we're adding a table to our baby names database, and we're getting the data from YOB, year of birth, 2010.txt. And that's actually, yeah, we're in that directory. And then we're setting up our schema with 2 strings and an integer, strings for name and gender, and integer for count. Okay, so let's load it up. Okay, so we've got our data loaded now. There's sometimes if it indicates your billing's not set up and you need to go set it up, there's a bit of a delay. So keep that in mind if something's not working and you keep getting this error. So we got our data loaded now. So now we can look at it. We can do a bq show baby names dot names 2010. That's what we called our table. All right, and it'll show it. And there you go. So we've got a lot of rows, 34,063 rows. And I guess that would align with how many unique names there are in the data set. And we can run a query against it. So let's determine the top 5 names for girls. All right, and we would do that like this. BQ query, select name and count from baby names, and we're going to, where gender equals F, we're going to order by count descending. Okay, and we're going to limit to 5, so we're just getting the top 5. Okay. And number 1 is Isabella, then Sophia, Emma, Olivia, and Ava. Okay, now let's take a look and see what it is for the boys. So look for male. And it is Jacob, Ethan, Michael, Jaden, and William. Okay, cool. Okay, so now that we know how to use BigQuery a little bit and we ran some queries, we added a data set, we're pretty much done with that data set now, so we can remove it. So we can do bq rm-r and then baby names. And it'll ask for a confirmation. We'll say yes, and it's removed. Okay, well that's all I wanted to cover for BigQuery, and I just kind of wanted to give you a glimpse of what you could do with it. And so go ahead and mark this lesson complete and move on to the next. Thank you so much for taking the time, and bye for now. Hi, and welcome back to the Google Cloud Essentials course. This is Brandon, and in this lesson I want to walk you briefly through the Ruby Google Cloud client. And there are now 7 native programming clients for Google Cloud, and Ruby's one of them. I just wanted to walk you through one of them to kind of show you what can be done with just a very small fraction of what can be done. Just a couple of things with the Ruby Google Cloud Client. All right, so the first thing we need to do is install it. So we can do a gem install Google Cloud. All right, and this will take a while. Okay, that's a pretty big install, so it takes a while, but it's done now. So now we need to authenticate, and we have to use a special authentication command here with Gcloud. So we'll do a Gcloud auth application default login. So this is a special command for when you're running application code on a system and you want the authentication to be available. You'd run this. All right, and it's going to give me a link, and I'm going to grab it. I'm going to go back over here to Firefox and plug it in. And I'm going to choose my account. I'm going to use my demo account. Allow. All right, I'm going to paste this command in, or this code in. All right, so now we have some default credentials set up. Okay, so now let's start running some of this code. Right, let's start using this gem. So we can do that in interactive Ruby, so IRB. I'm gonna open that up. Okay, and the first thing we need to do is require some gems. So let's do require Ruby gems. And then we'll do a require Google Cloud. We'll do a require Google Cloud Resource Manager. All right, I'm just going to show you some just a couple of basic resource manager functions we can run. All right, so going to instantiate resource manager now. Resource manager and assign it to this resource underscore manager. So Google cloud resource manager dot new. So we've got a resource manager instance. And now I can use this to say list all my project IDs. So I could do resource manager dot projects dot each do project, and then puts project dot project ID. So I'm just iterating this list of projects that the resource manager gives me. And end. And if I scroll up, there's all my projects I have. Right? And some of these are actually deleted, where I had typos. I had, deleted it after I had a typo for this BigQuery project, for instance. And it will show that. Now, if I do, let's do my project equals resource manager dot project, and then I'll, for instance, this one I've deleted that had one too many G's in it. I'm going to grab that, plug that in. All right, so we'll have this project object to work on. And notice lifecycle state shows delete requested. All right, so it's in a holding pattern, so we can undelete if that becomes necessary. All right. So it's not, we've asked for it to be deleted, but it hasn't physically been deleted yet. Okay, we could also do something similar if we iterated through here and we just wanted to put the name, so we could do puts project dot name end, and that would print the names of our projects as opposed to the IDs, and some of them have the ID as the name, but these, the cat time ones, they don't. So you can also add a label to a project. And so let's change our project to one that's active. So let's make it, how about cat time, Sinatra, Brandon 423. All right, so there's my current active project. And I'm going to say my project dot labels equals, and I don't believe I have any labels at this point. It's all right, it's empty. Okay, so we'll assign a hash to it, and we'll say env for environment, and we're going to say production. All right, now we can look again, and there it is. Okay, so if we took a look at my project now, we would see labels. All right, so we've got this property labels, env production. Okay. Now we could filter by label with this. And I'm just going to paste it in here. Okay. So if I scroll up here, we've got, let's see, where is that? Yeah, this command here, projects equals resource manager dot projects, and then filter. And we're filtering for the label env is equal to production. And it just returns this one project because it's the only one that has a set. Cat time Sinatra, Brandon 43. Okay, well that's all I wanted to show you with the Ruby client. I just wanted to show you some of the possibilities for an essentials course. I don't want to get too deep into client libraries and stuff like that. Just wanted to show you how it works a little bit. So go ahead and mark this lesson complete and move on to the next. Thanks so much for taking the time. Bye for now. Hi, and welcome back to Google Cloud Essentials. This is the last lesson. It's next steps. So thanks so much for making it all the way through the course with me. I just want to talk to you about next steps you can take to advance your Google Cloud knowledge. So you've gone through this course, you've got a strong basis in essentials. I would suggest exploring some of the other concepts that we didn't cover so deeply, like networking and maybe a little more storage, the big data and machine learning options. And the best place to go for that right now, and we're working on more course material as we speak, but is right here, the Google Cloud documentation. And this particular documentation is for storage. And if I click on docs here, so it's just cloud.google.com/docs. And it's organized in a few different ways. You can start with your favorite programming language and start viewing docs from there, or you can choose a topic. And like I said, so we've covered App Engine, compute, storage. One thing we haven't covered is containers. Okay, so the container engine. And Travis Thompson on my team, he's developed a new course, and it's in the Linux category right now. We're working on a Google category soon. And here's another course you might be interested in, Google Cloud Platform for the AWS user. But here it is, Google Container Engine. So you can really augment your knowledge with a deeper dive into Google containers, and they're really useful. You'll learn some things about Kubernetes and Docker, and utilizing containers and microservice concepts with your Google Cloud Platform setup. So it's a great course. It's just come out recently as well. So I would definitely look into that. Going back to the documentation, big data, machine learning are opportunities. There's new stuff coming out every day for Google Cloud Platform. IoT, for instance, their IoT platform has come out. It looks very promising, very interesting. So you might look into that. And I would say just experiment with it. Just just play with Google Cloud and try out things and see what you can do with it. And let me know what you accomplish with it. We're always happy to hear about what our students are doing, knowledge they've gained with our courses. So, and be on the lookout for more content for Google Cloud from us. And also take a look at the certifications. This particular course wasn't intended to prepare you for a certification directly, but I think it'll give you a good basis for starting to take a look at the architecture content. And I think we'll have a course coming out dedicated to that over the coming months. So, but yeah, that's what I would do for next steps, and also just dig into any concepts that you find interesting that we're offering here. There's a lot of coursework here you can pick from. So related stuff, like I said, directly related would be the Google Cloud Container course, but you could also take a look at Docker. There's a little bit of Git and CLI and Linux concepts involved with this course. So if you wanted to expand your knowledge there, you could take a look at those courses or those related courses. And also something that might be a good supplement would be a config management course, like one with Puppet, or also a CI/CD course like the Jenkins course. So there's a lot of good options to move on from here within Linux Academy, and there's also a lot to expand your knowledge on in the Google Cloud platform. All right, well, that's all I wanted to say. So thank you so much for making it through the course with me, and I hope you enjoyed it. And please don't hesitate to give me any feedback or ask any questions. All right, thanks so much again. Bye for now.